The cloud. Okay. Well, hello and good evening, everybody. My name is David Whitlock. I've been teaching the Advanced Java Programming and Advanced Programming in Java courses at Portland State for a very, very long time, and I'm really excited to be able to join you once again to explore concepts in software engineering and implement things using the Java programming language. Um, I'm going to start out here with some introduction to the course, some trivia. We're going to do a lot of stuff tonight, and just want to give you a preview. I'm going to introduce myself and also the graders. We're the people that will be supporting you in the course. And then we're going to sort of get an introduction to what we're doing. I'm going to talk about the syllabus. I'm going to start walking you through some of the tools that you'll be using throughout the entire course. Along the way, I'd also like to engage you in a discussion about your experiences learning remotely. Um, this is my second time teaching this course fully remote. And while I learned a lot last time, you all have much more experience consuming information remotely. I want to know what's worked for you, what hasn't worked for you, and some ideas that we have so that we can make the learning experience as optimal as possible under the rather extreme circumstances. Then we're going to dive into some Java stuff. We're going to create our first Java project. We're going to start writing some code. We're going to see some test-driven development. We're going to see our first couple of assignments that you'll get assigned tonight. You'll have a couple of weeks to work on them. Something called the Java Koans, which is a nice little tutorial way of learning about the Java programming language and some of the APIs. And then we'll also see some test-driven development. Lots of stuff tonight, and this is probably going to be the longest lecture. So, hope you had a good dinner, or go have a snack now. Stay hydrated. It's pretty warm out, but it's going to be a long haul tonight. We'll go until probably until 9:30. I'll try to keep an eye on the clock. Also, want to make sure that we can pace ourselves though. So I'll be taking several 5-10 minute breaks just to sort of let our minds calm down a little bit before we jump back into getting all the fundamental information that we need to be successful in the course and to start things off. So, I want to introduce our team who is helping you learn this term. First of all, me again. So, during the day, I work for a cybersecurity company called Tripwire downtown. We've been around in Portland for, gosh, well over 20 years now. We've had a nice relationship with Portland State over the years. We're part of the PSEP internship program. We're big fans of Portland State. It's so great to have, an academic institution right close to our office where we have access to professors and people and students that really, enrich the community in which we live. We're also joined by two graders this term. Pei and Stephen will be helping me give you feedback on your work. So they'll be doing the lion's share of the grading, while I focus on sort of your day-to-day questions, helping explain the assignments and helping you through problems. Pei and Stephen will be looking at your work, grading your quizzes, grading your projects, providing you with that feedback on how you're doing in the course. Let's see here. I don't think Pei could join us. Steven, did you have a chance to join us by any chance? Let's see here. Nope, I don't see him on the line. Um, I I asked them both to send a picture. Pei did. Steven didn't have a chance to get to it, so I found that clip art. He kind of looks like Casey Kasem, if you know who that is, the American Top 40 guy from the. Anyway, moving on. So, oh, a couple questions came through in chat. Um, I don't plan on. So the question is, you said this would be the longest lecture. Does that mean they will not always be around 4 hours long? It's my intent. Depending on the kind of conversations that we engage, I don't intend to be that long. I hope to sort of get people done by 9 o'clock because I get tired. Um, however, these are, as we'll talk about, the format of the class isn't always going to be lecture. I might be doing a lot of talking, but it's usually a lot of coding. I want things to be interactive as much as I love to hear myself talk, I can listen to the recordings of me talk. Really, what I want to be here for is you, to help you understand the concepts that we're covering on any particular day, the nuances or the specifics about the code that I'm writing, and the code that you see. So please ask questions in chat. I'll keep the window up here. It gives me a little audio. I don't know if it gives me an audio prompt or not, but I'll try to get things as quickly as possible. And if there's something that you see, maybe I'm sharing the wrong thing, or something doesn't immediately make sense, you can also feel free to come off of mute and ask your questions there. Okay, great. I'm just going to quick scan the chats. Okay, nothing else there. Good deal. Okay. As I said, this is a 100% remote class. And this is just because we are still, the campus is still closed due to the coronavirus, COVID-19. So all of our actions will be remote, and this is a different experience for all of us, myself included. And so the way this is going to work is that every Wednesday night for the next whatever it is, 8 Wednesdays, um, we will meet here on Zoom. So I've shared the link with all of you. It's in the class Slack. It's also on D2L. Obviously, you all found it, and so this is where we'll meet. I like to start promptly at 5:30. I want to be respectful of the people that like show up on time, people who come early and stuff. So we'll start right in. Um, I will be using breakout rooms a lot. Tonight we'll be using it to have a discussion about what it means to be remote and your experiences, as I was saying before. But in the future, we'll use it for pair programming, for mob programming. It's worked out really well overall. I'll also use Zoom for office hours. I usually reserve the hour before class, so 4:30 p.m. to 5:30 p.m. for office hours. Gives you an opportunity to ask questions about the content that we covered in the last week, or any last minute questions about your project. I'm also available via Slack and email, and if you want to have a one-off meeting, as long as our schedules can mutually accommodate it, I'm happy to meet to talk about specific questions or impediments that you're encountering during the term. Um, and in terms of the quizzes and exams, including the final, that'll all be done over D2L, which I think most people are familiar with. And so let's see here. Well, I'll talk more about that during the syllabus. So the quizzes are there, and then as far as day-to-day communication, that's why I leverage Slack. I have I'm one of those people that likes to have multiple channels for things. So like every project will have its own channel you can talk to. This is not the CS department Slack, and that if we did that, I would only have one channel for the entire class, and with so many people and with so many conversations, that I don't think that would scale very well. So I created my own Slack workspace, and I believe I've invited all of you to it. There's a link to it in the syllabus if you didn't have a link. So, but please join that, because when I want to broadcast out to all of you, I'm going to use Slack. It helps me engage in a real conversation, much in a real time conversation, also much more than email or using D2L or things like that. Okay. Um, as a quick note about registration and the size of the course. So, over the last couple of years, this course has become really popular. They added a graduate section, and so then we're essentially full. I think there might be a space or two left right now. And thank you. It's quite an honor to be able to teach so many of you. It's very gratifying to me to know that the course is interesting enough and has content that appeals to so many people. Or maybe you don't have anything better to do on a Wednesday night, and that's fine. Let me live my own little dream world. It's better for your grade in the long run. Anyway, but I did want to point out that there is a short wait list for the summer. If you are on the wait list, let me know, and let me know if you need any help getting officially registered for the course. I don't know how that works exactly, but I want to make sure that everybody who wants to participate in the course can. So reach out to me if you need some help. Matthew wants to get this programming intensive credit. Your wish will be granted in terms of programming intensive. So excellent. And this is one of the things that I can do because I can accommodate more people because we're all remote. I miss being on campus. I miss being in the classroom, being able to see you, have you all laughing uproariously at my jokes. Um, but this is the best. This is what we're doing right now. So I can accommodate more people than I could if we were in person. But we don't have exactly the same experience. So there are a lot of you though, and so I'll try my best to scale my own communication and my own responsiveness to this many of you, and I've asked the graders to do the same. But I have a full-time job, and there's only so many hours in the day, so I appreciate your patience in advance. If I can't be as responsive as perhaps some of your other professors, or as perhaps you'd like me to be. Okay. Any questions before we dive into the main part of lecture? That was also a preamble.
Pretty much covered my main one
Oh,
in
I'm
the
sorry,
comment.
Andrew. Could you repeat that? Sorry, you're a little soft color coming in.
Sure. I already sent one in the comments. That's the only one I can think of right now. I guess to elaborate,
Oh yeah.
last time you taught this remotely, did it usually end up as shorter lectures?
Um, I think so. Hey, if you really want to know how long it was, you can go back and look at the YouTube videos from last time. I record all the record all the lectures and put them up on YouTube.
Okay.
And so you can see about how long they averaged. I think, yeah, I mean, it was, my recollection, and over the years I found that yeah, the first couple of weeks there's a lot to cover, there's a lot of back and forth, and so then it takes closer to the 4 hours, but then it's including breaks and everything like that. I like I said, I hope to get us out of here by 9 o'clock because that's my bedtime.
I have two other questions, if you
Yep,
don't mind.
not at all.
One is in the presentation, it said that breakout rooms would be used a lot, and you want it to be very interactive. Does that mean there's time during class where we're put into different groups and then supposed to work on an assignment together during class, or what?
We'll talk more about that. Maybe not so
Okay.
much in detail tonight, but yes, a component of the course, and as we'll see, ultimately a small component of your grade, is based on collaborative work. It's part of what I want you all to experience. It's important. Working with others is an important part of software engineering. And so then, we're here in this classroom setting, in this academic setting, and it's a component that I've added to the course. And overall, the students have found it interesting. They found it value to be able to experience this in sort of a safe way, in a way that only makes your grade a little bit. So I'm not gonna. So it's not like group projects per se. And as a matter of fact, there's quite a distinction between the work that I expect to be done on your own and the work that I expect to be done collaboratively. But yes, every pretty much every night there'll be some small group discussion or some small group activity, often a program activity that you'll have the opportunity that you'll be participating in.
Okay, and the last one is basically in the course homepage. You said that you don't follow the book super closely.
Yeah.
Would you say that it might be more productive instead of reading the book to watch the recordings of the previous remote term that
Oh.
you did ahead of time as like
Yeah, and actually, I'll get to the
credit for that?
specifics about that. Yeah, shortly. But yes, the textbook is really a reference, and honestly, a Google search and Stack Overflow and tutorials online will give you just about as much information and save you whatever it is, $40 for the for the book. And so no, this is as a matter of fact, this is anything but a follow the book course. I have the luxury and the privilege of being able to set the syllabus and set the agenda for this course. And so it's not like I'm like, okay, here's like Java 101 and everybody's doing the same thing. No, I mean we have an opportunity to explore all sorts of different things in here, and I don't want to be bounded by a textbook and somebody else's view of what we should be learning.
Okay, cool. Good to know. Thank you.
Okay, excellent, Andrew. Thank you for those questions. Those are really great. Anything else? Okay, so um this is the course's homepage. I'm going to post it in chat. Um, this is my intent with the course homepage is that this is where you start with the course, and every week this is where this gives you the map of the world, to help you navigate what it is that we're doing here. And okay, it might look like Alta Vista circa 1997, but the most important information is here in the middle. I've got a bunch of links off to things that you probably find interesting on the left and right. But what I encourage you to do is check in, before class, with the topics that we're going to cover. Um, in terms of the structure of the course, I don't know, probably 5+ years ago now, I inverted the teaching style. For many years, I lectured, and so what we would do together in class is that you would listen to me, and I would say things about Java, and I would show you slides with Java code on it. And after I did that for a long time, I realized, wow, if I find this boring, it's got to be excruciating for the students. So what I did is I recorded all of the lecture content. This is the content that talks about the language concepts, the APIs, it gives you all the introductory information about the content that we then work with in class. And so what we do in class is that we code together. You watch me code. I explain the concepts through programming instead of just me, showing you some static text on the slides. I found that it's more effective for the students. It's more enjoyable for me. It's a win-win all around. And since everything's recorded, and again, I record not only the lectures to watch beforehand, but I'm recording this this Zoom session, and I'll post that to the YouTube channel also. You have an opportunity to go back and review things, to maybe see what I've done, or you're like, oh right, he was doing the debugging thing. How did he do that? Or in the off chance that I say something too fast and it doesn't make sense, you can go back and review that also. I want to make sure, I want you all to be able to engage fully in the course, and there's a lot of information, and I want to make sure that you have the opportunity to go back and review that and fully understand it, internalize it, provide me with feedback and questions. So I put a lot of stuff on YouTube. Um, Tonight will be okay. So anyway, so sorry. So what I recommend every week, there are some preview materials. The stuff for this week talks about sort of getting set up with our environment. We'll also cover that this week. A couple people pointed out to me that there are a couple things that are out of date in here. I apologize for that. I had to make a couple last minute changes to some things with regards to how the Maven projects are built. I didn't have time to, and actually, not I didn't have time. I flaked. I didn't realize I needed to go back and update things in the Getting Started screencast. So please ask questions if things don't make sense. And then I also have a couple of lectures that talk about unit testing with JUnit, updated for JUnit 5, and then also building projects with Maven. And what we'll see tonight, though, we'll be using these tools. I won't be going so much into the philosophy behind them, or a lot of the details. We'll see them in practice first. Before we dive into that, though, I want to cover the course syllabus. I want to talk about what it is that we're where's it? Hide that. What it is that we're doing here and how we'll go about doing it. Um, so if I had to have a goal statement for the course, it's I want us to learn about Java. I want us to learn about contemporary software engineering using Java, and I hope that it's fun. For me, you should probably tell I'm pretty passionate about this. This is my career. It's what I also like to share with other people. And I hope you too find it to be something that's interesting, something that gives you some opportunity to be creative, learn some new topics, and also to have some fun. In terms of how we go about doing it, there'll be a number of different aspects to the course. So I have, again, all lecture material online. There'll be what we do in class. And so you'll be seeing me code a bit. You'll be doing a lot of coding yourself. And we'll be talking about it, about your experiences, about what worked, what didn't work for you, how all that stuff works. And then you'll also get to experience some of that, not only coding on your own, but also in both pair programming and mob programming. And I'm not going to go into the details details about sort of how exactly all that works tonight. We'll save that for next week. There is a handout though if you want to read up on it. It's under the week 2 section of the syllabus of the homepage. You're going to be seeing a lot of code in class. There's going to be the code that I write in real time, but I also have a lot of code, a library of code that I built up. It's all on GitHub, and we'll take a look at that kind of stuff later. That hopefully it helps you learn the Java language and the Java APIs by reading other people's code, by reading code that I've written, so you can see how code is structured, so you can see how the APIs are used, how software is developed with Java. As far as individual work goes, there is a 5-phase project in this class. We'll see the first phase of that project tonight. It'll be assigned to you. It's due in 2 weeks. And you get to build up a code base over the 5 projects. It starts out very simple, a command line application that just creates a couple of classes. That's meant to get your feet wet and make sure you can use the environment, use Maven, use IntelliJ. But it culminates in an Android project that allows us to get experience developing applications for small devices like phones and tablets and stuff. I've always had a user interface component to the course. It's how software is developed. It's the kind of software that we write these days. And I want to make sure that you then have an opportunity to experience this. And while it's kind of a hard right turn in terms of the tools that you use, in terms of the things that you need to know, overall, I've gotten very positive feedback over the years about giving the students the opportunity to be creative and explore some new aspects of software development. Dimitri, no, it's not in Kotlin. It's in Java. It's not advanced programming in Kotlin. It's advanced programming in Java. But if you really want to use Kotlin, we can talk about it. Okay. Um, No, I mentioned I mentioned that we'll be talking about Android. That's sort of the culmination of everything. We're going to be seeing lots of different topics, lots of different areas of Java programming, just software development in general. So we'll be learning about the Java language syntax. We'll be doing object-oriented programming. Java is an object-oriented language. The APIs have objects and object hierarchies, and so I feel that you'll get a good experience using object libraries to build your programs. We'll be learning about a bunch of the standard libraries that come with Java, classes for building collections of other objects, for doing I/O, sort of fundamental stuff like that. Question, Matthew? Yes, there is a Slack channel. If someone could post the invite link in the chat, I would appreciate it. It was also in an email that I sent to everybody who was registered like 3 days ago. Also, sort of like at the beginning, the first 4 weeks of the class is really about. Oops, thanks everybody. Is really about sort of getting your feet wet with Java and figuring everything out. In the second half of the class, we start doing more advanced things, like developing web applications. Now this will be a REST API, so you're not going to be writing HTML, you're not going to be writing JavaScript. Instead, we're going to be developing a REST API, and you'll get to learn about web applications in Java. You'll learn about the HTTP protocol, a little detour through sockets and things like that. Good experience there. And then there's some more advanced topics that you can learn about in the lecture, such as dependency injection, mocking out objects for unit testing, and then we'll end with Android. As you can see, there's a lot of information that's covered. We go at a rather brisk pace, but I hope that between giving you the opportunity to ask questions in class, on Slack, working with each other, and having access to the materials online and the YouTube channel, that you'll be able to, have the information that you need to be successful. Dimitri also asked, will we touch JEE at all? Only the web parts of it. We will not be covering, object relational mapping like Hibernate, or we'll be using, the examples that I use Google Juice for dependency injection. We're not using Spring. That's not this course. That would, and since my intention here is that we kind of start from just knowing the language, that would be a lot to cover in a handful of weeks. And so no, that those particular topics are outside of the scope of this course. Yeah. Any other questions about the content of the course before we start talking about grades?
So you said that group projects are not the thing you're talking about with the in-class work, but are there group projects at all or no?
Um, no, not No, there's
Okay.
not. And actually, I'll talk about the. I'll get to that right now with the with the grading policy because I think it'll be more clear that way.
Okay.
Oh, Lee asks in chat, will we need Android Studio for the Android phase of the project? Yes, and we'll get to that in a couple of weeks. But yeah, if you've already used it or you've already got it, upgrade to the latest version. Yeah, good questions, everybody. Okay, so let's be honest, grades are important. So I want to make sure everybody's clear on what determines your grade. Um, the bulk of your grade is based on the code that you write and the code that you write every week, and so that's the multi-phase project. And there's also an assignment called the Koans. So there are 5 phases of the project. There's this Koans project, and then these are multi-week efforts that you go through. That accounts for 60% of your grade. So the majority of your grade is the code that you write. It's a program intensive course. Um, I don't want I took a couple courses in college where like the majority of my grade was determined by the final exam. Nope, that's not. I don't want this to be that kind of course. You have to stay with it every week. You just can't cram for the final exam and expect to get a good grade. There's also quizzes, and so over the term there are 8 quizzes. I dropped the lowest grade in case you flub something or whatever, and so then the 7 that count are worth 3 points or 3% each for 20%, 21% for the quizzes. They're all administered on D2L. And note that 2 of the quizzes are surveys, implemented as surveys in D2L, and so that's often a slightly different section of the user interface. I think it's all there in the calendar view though. Um, there's also each so 7% of your final grade is 2 reflections on your experiences with pair programming and mob programming, and so then there will be 2 classes in which we'll do a pair programming activity, and another 2 classes which we do a mob programming activity, and you must attend and participate in 1 pairing session and 1 mobbing session. You're free to do both. And then in terms of the assessment of that, I want to hear about your experiences. And so I'm going to ask you to write a reflection, a couple paragraphs about what you observed. And so we'll go into more detail about this next week, but that is, how I assess your experience doing mob programming and pair programming. And finally, the final exam, that's worth 12% and only 12%. Because again, I want to make sure that you have a chance to get feedback on your work all along the way. And there are lots of opportunities to do that, right? Because there's pretty much a quiz every week. And starting in 2 weeks, there'll be a project that's due every week also. So there's a lot of work. Question. Let's see here. Oh, a couple questions coming. VS Code, is that okay? If you can make it work, great. I use IntelliJ. What I support in the class is IntelliJ. If you ask me questions about VS Code, I'll be like, go ask Google. And same thing with Eclipse. I want to choose one tool, and I chose IntelliJ. And then also a question: what determines the material that a quiz will? Yeah, you can use Vim also. What determines the material that's on a quiz? Good question. It's the material that was sort of covered in the project the week before. The first couple quizzes are sort of more general topics, but usually it's like, hey, in your first assignment, you'll see that you'll be working with object-oriented programming. Great. I'm going to ask you some questions about object-oriented programming in the quiz the following week. More stuff about your grading. There's lots of assignments that are due. You have 2 late days, which you can use well anytime you've got a project. And so then hey, projects are all due before class. I want you to be in class. I don't want you to have to choose between, oh, do I do my project or do I go to class? And so then do your project before class. And so that's when it's due. So it's whatever 5:30 on Wednesdays. Um, uh, And so please, so have stuff ready so you can be fully engaged in class. But if you're late, or you find a last minute bug that you can't fix or whatever, that will start the clock on your first late day, and so then you can use two of those during the term. I also let you resubmit one project without penalty for within 1 week of the original grading. So I've asked the graders to get you feedback on your projects before Monday. So things are like due on Wednesday, and then hopefully you can get your grades and feedback on before Monday. And so then you'll have a week after that to hey, let's say you had a fundamental misunderstanding about how the command line should be formatted. Every test case fails. I don't want you to get a zero on that. Clearly it's probably like a one line change to get everything to work. You get one of those for free. Otherwise, my policy is not to accept any other late work. However, I want you to be successful in the class. I'd much rather have you reach out to me and let me know that, I'm running behind this week, or hey, I got sick, or hey, I got something else. I'm not going to be able to get it done. Let's make sure that we have a plan to make you successful. But don't come to me on the last day of class and say, oh, hey, can you I finally got all my work done from the first week. Will you regrade it? I'm not likely to go for that. I want to make sure that you're engaged, and I try to be reasonable. But I even have my limits. Couple questions. Are there two final exams? There's only one final exam. It only there's only so there's not a midterm, if that was the question. There is just the final exam. Another question about the cones. Better to do the cone before the project, or always complete the projects first? I don't know if I have an answer for that. My intent is that, and we'll talk about the cones later on tonight, is that the cones are spread out, that you sort of do a little bit every day or every couple of days over several weeks. And so I don't think it's necessary to do all of the cones. Remember, it's a lot of work to do all of the cones before you start your first project. So it meant to be done in parallel. Oh, Harsha. Oh, you're right. You're giving away. We'll talk about the true nature of the final exam much later in the course. I didn't realize that both of those were exposed yet. Harsha knows how to use D2L to find all sorts of interesting stuff about the course. Nice. Okay. Oh, okay. So that is like your individual grade. As far as your letter, sorry, your numeric grade. In terms of the letter grade, I reserve the right to grade on a curve, but I don't usually have much of a curve. My experience has been is that the way the content is paced, and the way students perform, I have a nice distribution, and so but hey, if I've got if maybe it's a rough term, something goes sideways, and we have a lot of people that whose numbers would put them in one grade, I'll adjust it to another. Oh, and then finally, there are two sections of the course. And by the way, I make no distinction in terms of the content for the two sections of the course. So all the assignments are the same, all the expectations are the same. I do have separate curves for each section, though. I don't think it's fair to assess an undergraduate student exactly the same as a graduate student. So again, I reserve the right to have a different grading curve for the undergraduates and the graduates, although I haven't had to do that in many years. Because again, things work out pretty well. Okay, any questions about the grading policies? I know there's a lot there, and we've covered a lot of content.
So I guess my question would be then, how does attendance count? Is attendance required? Is it not required? What happens if you miss classes?
Excellent question. I don't take attendance. There are things though in class that, and I guess the only thing that is only time is absolutely required is to participate in your one pair programming and your one mod programming. We've all got lives. I completely understand. It's one of the reasons why I record the lectures to make them available. Hey, things happen on Wednesday nights. You're super tired because you pulled all night the night before. Hey, you've got some family obligation. There's a marathon of Felicity on that you want to watch, whatever it is that right? Our lives happen. I want to make sure that you can do that. The things that are required to happen in real time, I guess, are participating in one mob programming, participating in one pair programming. The final exam, I guess, is also something that happens in real time. That's not something that well, if you let them know beforehand, maybe I can accommodate it. But those are the things that I want to make sure that you're here for.
Okay, cool. And this is a dangerous question, but the other one is, I assume we're already marked as present. So as far as D2L is concerned and us not getting dropped from the class, because I know we have to attend
Oh
the
yes,
first.
thank you. Right. So I sent out an email a couple of days ago, saying, hey, you got to be here on the first day. Otherwise, if I don't hear from you, you're gonna be dropped. Turns out, a couple of people have already dropped out. There's enough room for people on the wait list. So yes, if you are registered for the course, you will stay registered for the course. I don't have there seems to be enough room for people on the wait list. And so no, I'm not taking attendance tonight. I'm not going to send out some survey. I'll work it out with the department. Shouldn't be a problem. But if you are on the wait list and don't know how to you don't know how to get enrolled in the course, reach out to your faculty advisor, or if you need help from me, reach out to me too. But all I'm going to do is ask the department how to make it happen. Bennett asked, open book, open internet on all the exams. I'll reiterate this again later in the course, so you don't need to remember. But open book, yes. Open internet, no. Sorry. Maybe other professors do it, and maybe I'm old-fashioned or something. But now I don't have any way of enforcing this. So, honor code, and actually we'll talk about plagiarism here in a moment. But no, I mean the intent is that for the quizzes, for the exams, is based on what you know. I'd like to think that the quizzes are reasonable enough that they assess what you ought to be learning by reviewing the lectures, by doing the homework, by doing the projects, by being engaged in class. And so then no you can't Stack Overflow all the I guess it's a verb now. You can't look up the answers to the quizzes on the internet. That while maybe that's what we do in the real world, this is in the real world. This is academia. I don't even know how to explain this to me. I'm the professor. I can do whatever I want. Yeah. Let's see here. Question: are the quizzes at a set time or just due by the end of the day? They're also due right before class. And so then please be sure to keep up with them. But yes, they have cutoffs, and I think that's all discoverable on D2L. Okay, great. Any other questions before we move on? Okay. It goes without saying, but I'll say it anyway. Don't cheat. Um, I'll find you. Okay. Story time. I've teaching this course forever. And back like in 2000 2002, I had some people who were cheating, like copied each other's work. I use this tool called Moss, where I submit your source code for your projects, and it goes through and it finds code that looks oddly the same. Sometimes it's direct copies, but it's also smart enough to know it's like, oh look, you changed some comments, you changed some variable names. Oh look at that, right? It's smart. Um, and so and I didn't have a problem with cheating for years until last summer. And so I want to iterate a couple of things to you tonight. First of all, the definition of cheating. So, it is cheating to submit for credit work that you did not create or allow your work to be submitted as the work of another student. Um, and so then, but it's also reasonable to say, but wait, Dave, in this course, we do mob programming, we do pair programming, we're supposed to work together. For that stuff, yes. But then there's the things that you're assessed on there are projects that make up the majority of your grade, and that is meant to be individual work. And by individual work, I mean stuff that is your own ideas and your own implementation. So you can talk to other people all you want. You can draw pictures. You can here remotely. It's not like going to a whiteboard or anything. You can look some things up online. But I think we all know what it means to copy somebody else's work. And so don't look at other people's code. don't look on GitHub for other students, code from this course. I've got all their submissions too, right? I keep all the submissions. I've got 20 years worth of code that if I wanted to, I could go compare yours against. And so I just want to, make it clear that, don't go looking for other people's work. And also during the course, don't put it in a public GitHub repository. Don't put it out on, other places that people can see. Um, there is some work in this class. Again, the pair programming, the mob programming, that is collaborative. That is, meant to. You'll put that. You can put that on a public GitHub repo. That's great. That makes a great portfolio for you. But in terms of the individual work, that is everything else, and that is not meant to be shared with other people. If you find yourself questioning, you're like, oh, we were, I was working with these two people on this mob programming thing in class. It was really great. Can we do it for our project? No. But, ask me about it. And I'd much rather, discover code that looks a little bit alike. It's like, oh, right. They were saying they were work together. We'll work it out. Last year, I was surprised to find that there were two groups of students who had worked together and somehow were confused about the nature of collaboration on the mob programming versus the individual work. So this year, I am dedicating far more time than I thought I would to explain to you don't copy other people's code. And I will also refer you to the academic uh, conduct statement from Portland State. Okay. Any questions about cheating? Nice. Oh, and yes, GitHub offers private repositories for free users. Yep. And students too. And so we'll talk about GitHub here in a moment. We'll start. It's almost time to get to some of the fun stuff. But before that, I just a whole bunch of miscellany. Like I said, the website for the course is home base. It's where you can get to all the recordings, where you can get to the lecture notes as PDFs. And please come to class prepared. I'll take questions at the beginning to open things up to answer any questions that you have, but I don't want to use class time for lecturing. I want to use it for collaboration and encoding with you all. Something I've heard from students year over year over year: don't wait until the last minute to start the projects. They might seem easy on paper. It might be like, oh yeah, I'm just writing some code, does some file IO, and then at the end of the course they're like, oh boy, there were a couple times where I was I waited too long and spent more time than they wanted to on it. So don't wait until the last minute. We'll cover more on this, I think next time. We'll talk about how I expect you to document your code. But write. I recommend that you document your code as you write it. Write some documentation. Write some code. Make sure that you can explain what you're doing in words in addition to code. Please ask questions when you have them. I I already know all this stuff. I don't need to hear myself say it to you. I'm here for your learning benefit. But if you're struggling with a question and you don't let me know, I'm not gonna be able to answer it for you. So please, in chat, in voice, send me a Slack, send me an email, or whatever. I don't want you to be stuck, impeded, or embarrassed because there's something that you don't know. Oh, a quick question here about comments in the code. I do, and next week I will dive into the details of what exactly that means. Okay, this is a senior level course. This is also offered as a graduate course. There's a lot of work. It's programming intensive, right? This is meant for people that already have good fundamental skills in programming and want to expand their knowledge in Java and contemporary software engineering. If you're taking other courses with lots of programming, your operating systems, your compilers, other programming intensive courses, take a look at your schedule. I want you to be successful. I want you to be able to, get what you can out of the course. I don't want you to hurt yourself to do it. It's offered every year. There are other courses, other programming intensive courses that you can take for that requirement. And so then, make sure that you're doing all right by yourself. I've had, a number of students over the years who push themselves too hard, and it's just not worth it. It's not worth your physical health, your mental health, the impact it has on yourself and your families. I have a lot of code. Go play with it. I have it out there for your benefit, um, and uh, and so please use that. Question about will I survive this class in PSEP? PSEP is an internship program. I've had lots of PSEP interns come through over the years, and they said yeah, that's it's programming. Although a lot of them have also told me it's like, oh hey, I'm working at a company right now that's using Java, and I understand things so much better because I've taken the course. Or it's like, oh yeah, right, they were talking about Maven at work, and now I understand what it is. So I like to think that in some cases it's mutually beneficial. Plus, you can tell them how this course it does mob programming and how that's cool. Okay. Um, like I said, my office hours are held the hour before class on Zoom. We'll use the same class link unless you want to have something private, and then I can certainly arrange for a private Zoom. Um, oh yeah. I use Slack for real-time communication. I guess in the past, I didn't do it this way this term, but in the past, there's a survey program that you run that sort of tells me who you are, and then I'll follow up with an invitation to join the course's Slack group. Um, but I've already shared that with you, and thank you to the people who posted it here. Hopefully, everybody gets that. If you know of someone who's in the course who isn't on Slack, help them get on Slack, or reach out to me and I'll help them get on Slack. This is where you find out things like, oh hey, we're gonna be starting class late, or hey, assignment's been graded, check your email, stuff like that. I'm also available via email. There's my old school cs@pdx.edu email address. I like that because I can spell it. It's my last name. Note that there's another David Whitlock at Portland State. It was the craziest thing. So Whitlock at pdx.edu is somebody else. So some dude that's like in the art department or whatever has been getting all these emails about Java questions, and I'm sure he doesn't appreciate it. If you use my PSU email, like through like if you're sharing a Google Doc with me or whatever, my PSU email is whitlowcd at pdx.edu. I will reply to that email. It's just not one that uh, is easy to remember. There's another link to the class webpage. And one of the first things that I'd like you to do to make sure that you can run a Java program on the CS department's machines. Oh wow, does it actually not say that I have to run this on the CS department's machines? Sorry. Log in to the CS department machines, run this command line, and what it is, it's a simple little program that prompts you for some questions about yourself, your first name, your last name, et cetera, et cetera. And what that does is, first of all, demonstrates that, yep, you've got your environment that you can run a Java program in, but then also it'll email that information to me, and I use that for a gradebook tool that I wrote. I don't record all the grades in D2L because it's slow, like to manually enter things with so many students and so little time. I've had to automate a lot of the things about the course, and this is one of the ways that we can provide input into that automation is by running that program. So please run that shortly. But do know that you only need to run it once. So just give me that information once during the course, and then I'll put you into the gradebook. And again, that needs to be done on the CS department machines. Oh wow, that was the syllabus. And what was it, like 10 o'clock at night already? I've been talking for a while here. 6:17, 45 minutes. Lee, how about you post the error that was run on the CS machines? And I'll try to help you out there. But any other questions about the syllabus in general, what the course is going to be all about? Oh, interesting. Let me check. I think I know what that might be about. Yeah, I guess it would be nice if I actually granted you permission to do that. Sorry. Please try again. Yay, good. Okay, sorry. Of course, I only run it as myself, right? So I never think do people have the ability to do that. Okay. Sweet. Okay. Um, let's start writing some code. Let's start getting set up. Okay. Oh, hey, fun Zoom interactive stuff. So, using the reactions in Zoom, choose your favorite one. Indicate whether or not you have worked with GitHub before. Thanks for some people saying no on stuff. Okay. Most people have. Yeah, a couple people haven't. That's fine. Not a requirement. I sort of want to know how familiar people might be. Okay. People are changing their minds. Okay, no, start coming and go in there. Excellent. Okay, good. So we're gonna do some stuff with Git. We're gonna do some stuff with GitHub. I'll provide some uh I'll provide some a little bit of background, but I won't go into too much. So an important part of development and in writing code and software engineering is to be able to share code with others. And code is written in files, and collaboratively editing on files can be a challenge. And so then, in order to provide a tool for multiple developers to work on the same code base, there are these things called version control systems or version control systems, where the whole idea is that you have your own copy of the code and you can make changes to it, and then you can easily share it with others. And more importantly, when two people make changes to the same code, there's a way to reconcile those changes. There have been a number of these version control systems developed over the years, and one of the ones that's become that sort of emerged as the most popular, the tool of choice for many developers, is a tool called Git. It was initially developed by Linus Torvalds and others for Linux, and right now though it's used for all sorts of code bases. There is this website called GitHub, which is now owned by Microsoft, that allows you to use the Git tool to host your code on the internet, so that anybody can use it, anybody can share it, anybody can contribute to it. And we'll be using GitHub a lot in this course to for a couple of things. We'll be using it for sharing code in amongst ourselves, and then mob programming and pair programming. But we'll be also using it individually to have well, first of all, serve as a backup, right? You make some changes, and then you go say, hey, go store my changes, store my latest version of my code up in GitHub, up in cloud. So that if you mess something up, you can go easily get it back up. But it also, I found, is a really good way of transferring your code from your local machine to the CS department's machine to make sure that you've gotten all of the changes and stuff. And we'll see examples of how to do all of this very shortly. Um, I also use GitHub to help you get started with writing code in the course. So, uh, Java programs, Java projects. So it consists of multiple source code files, and might have other things like in source code files for the main program, and what's being in tests are also in source code. And then there's also there might be other files like images and text files that have display strings and stuff like that. That all need to get created that all form a Java application. But there's a lot of code here, and there are we use this tool called Maven to build all this stuff, to do the compilation, to run the tests, to bundle everything together, and then ultimately so it can be distributed and run. And there's a lot of stuff to get set up, and I in the course, especially at the beginning of the course, I want to make it as approachable for all of you to start writing code in Java, because that's what the course is all about. The course isn't about figuring out how to get Maven to work. I want to make that easy for you. I want you to know what Maven does. I want you to know how to use it, but day one, I don't want you to have to figure out how to configure all of this stuff. So I created this Getting Started repository for the course, and I'll share the URL for it right here so you all can play along at home. And I'm going to walk through what's here in the repository. I'm going to show you how to do some things, but feel free to go at your own pace, which might be slower or faster than me, and follow along. And because what this will do is sort of get us all started to get us all on the same page when it comes to getting started with the course. So I've got a big old bunch of text that I'm going to glance through, and we're going to work together to basically at the end of this, everybody will have a private GitHub repository. Or rather, after following all these instructions, everybody will have a private GitHub repository that has the source code that that has the beginnings of the source code that they will use in this course. Okay. Now, there is a command line tool called called Git that you can install, and it is the thing that then drives. Well, it is a thing that then communicates with GitHub to get what's called the Git repository, the code repository that we're looking at here. So you need to have Git. Some of you who have used Git before have probably done a Git clone of a repository. We're going to do a special kind of clone here because in GitHub, because what's going to happen tonight, you're going to take my repository and make like your own copy of it. And starting from here on out, you're going to be working off on your own code. It's not going to be associated with my code anymore. It's just to get you started, and then you're going to start doing your own things. So we're going to have a special kind of clone that's going to be a repository that you own. It's based on mine, but you own it. It'll be in your own GitHub. Sorry, or organization. It'll be yours, not mine. For students, so anybody with a .edu email address, you have the opportunity to create a GitHub account that gives you free private repositories. Private repositories. So right now, you go to this URL. It's a public repository. Anybody on the internet can see it. We'll see in a moment here how to create repositories, and an option for creating repositories is to create private ones for the code that you write for your projects. Please put that in a private repository. Otherwise, people on the internet will be able to see it, and they might plagiarize off of you, and that leads to uncomfortable conversations. The first thing that you do is create a private repository. I have a link off to how to do that there. I recommend that you name your repository Portland State Java Summer 2021. I am going to do that, but I'm going to make a public one so that you all can see it. So this is going to be different. I'm going to create a public repository. I want you all to create a private repository. So let me actually go up here. Sorry, I've got a whole bunch of windows going on here. And I'm just going to, there you go. Okay. In the top right here, there is a place to create a new repository. It's my owner, and the repository name will be Portland State Java Summer 2021. Let's see here. You can put a description you want, code that we write together in advanced programming with Java. I want this to be a private repository. For this repository, because we're going to do a little dance here to get code from my repository into your repository. Do not initialize it with anything. Just create an empty repository, and we will start from there. So again, that was in the top right corner. You go create stuff, create a new repository. Please name it Portland State Java Summer 2021. Yours is going to be private. Mine's going to be public. Yours I'll be private. And I will create it. Okay. Now it's taking me to this URL, right, which is for this repository that I just created, and it's empty. It's got nothing there. As a matter of fact, it's like, hey, why don't you put something in here? And we will very shortly. So I'm going to go back to the Getting Started repository, Getting Started instructions, and start following it there. Okay. Now, there's a little bit of magic here, and basically what we're doing is we're creating what's called a bare clone of the Getting Started repository that we're then going to push up into the Portland State Java Summer 2021 repository. And don't worry if this doesn't all make sense to you. It's not supposed to. This is one of those times where just like, trust me. Oops, and I'm logged in there yet. And just follow along. So sorry, I'm gonna make my screen a little shorter so that everybody can see it a little better, perhaps. Okay, so I'm here in a folder that I have that is called Git. It's where all my repositories live. So I copied this git clone dash bear command here from the page. I'm going to run it. So what this does is it goes out to GitHub and it clones the repository, meaning that it makes a local copy of the repository, but it's bare. It doesn't have a connection back to the original repository because we want to do the following. So this created a file called Portland State Java Getting Started.git, and so that's a directory. As a matter of fact, .git. That's got, actually, it doesn't even have your source code. It's just got all of the stuff in the .git folder. And then what you want to do is you want to take this information here and push it up to your Portland State Java Summer 2021. So actually, before I do that, just to do a little bit of hocus pocus here. Sorry, I'm moving around all of the Zoom stuff. I am going to open up my, I'm going to open up my Summer 2021 repository here in a different window or different tab. Okay, so I did this. A question from Bennett: can the repositories be made public eventually down the road for job searches? Eventually, yes. Uh, if you wait until after, please wait until the term is over. That way, ideally, as you're getting closer to graduation too, someone might find it. But I understand, and you're actually completely reasonable to want to take this code and let other people see it. So please just wait until the end of the term. Okay. Then we want to issue this magical command, which does this push dash dash mirror, which will then take this copy of the this bear clone and then push it up to the push it up to the to push it up to your summer 2021 repository. Here in the URL, you need to replace the your GitHub user with your GitHub user. So for me, I'm David Whitlock. Very original, I know, but you know it's me. Oh, and I have to do an HTTPS. I don't even know what my password is. Sorry, I am going to instead use what is the, there you go, GitHub. So I always use SSH keys because I have no idea what my GitHub password is. So I'm going to use this instead. Actually, I think it's just like this.
I have a quick question about this.
Yeah.
I already set up this repo like about 10 minutes before class,
Yeah.
but I gave it a different name. Is that a problem?
Nah, it won't be a problem.
Okay. Yeah, I just keep it with the standardized naming scheme that I use.
Sounds good. It's
Okay.
private. No one's going to see it. Okay. So sorry. You can all use HTTPS because you don't have to set up SSH keys, and you probably know your GitHub password. I don't know my GitHub password, so I'm going to use this protocol instead to push it up. Cool. So that just pushed things up to the Portland State Java Summer 2021. And now when I go to the tab and I refresh, I see all of the changes that came in from the getting started, which means that now I have, and now you soon will be able to have all of the code that's here. You also have all of the revisions and stuff, but you'll have all of the codes that'll help you get started in the course. I want to pause here for any questions. And is anybody who is following along encountered any problems or has anything that they want to ask about?
You should explain how to set up the Java environment on the Linux servers.
Oh,
And
thank
okay,
you.
okay.
Yes. I'll get to that in a little bit. Once I've built it locally, then I will show you how to do it on the on Linux servers. Good call. Bennett, I got a command not found on the terminal. So is that command that can't be found Git? If so, you'll need to install Git, and I've got a link here to get started. And Git works on both, Windows and Linux, of course. Okay, now that I've done all of that, I don't need this Portland State Java Getting Started .git anymore. Oh yes, and you'll get an email from CodeQL. All jobs have failed. Yes, that's not expected, and I'll talk a little bit about what that's all about too. Oops, override that. Fine, RF.
I have a quick question.
Yeah.
Does IntelliJ have like a plugin or something that allows it to interface with a GitHub?
Absolutely. And we'll
Cool.
see that once we get IntelliJ going too.
All right.
And will it work with Git Bash on Windows? I believe so. It always has for me. Okay. So delete the .git and now do the checkout for real. So now I'm going to so instead of the push mirror, again, I recommend that you all, it'll be easier if you use HTTPS. I'm instead going to use this URL. And so what git clone does is it makes a local copy of the repository that is tied back to the remote repository. So what you can do is you make changes locally, you can commit them to your local repository, and then push them up to the remote repository. And what this allows you to do then is make your changes and then synchronize them across multiple checkouts. And we'll see that when we go and log into the school's Linux machines. And we'll do that shortly. Okay, so that is this piece of initial GitHub magic that lets you get started with the project. So now you've got this GitHub repository that lets you that lets you do some Java things. Let's start doing some Java things. In order to do Java things, you need the Java development kit, and I've linked off to how to get it there. I've tested everything with Java 16, which is the latest version. I also make sure that it works with Java 12. If you're using an older version, either one will be fine for the code in this course. Right now, the repository doesn't have very much. It's got a bunch of scripts for creating projects. It's got a top level Maven project, but we want to have some. We want to start writing some code. We want to start having some a Java project that we can work on. So the first one that I'm going to do is I'm going to run this create project 0 script. And what this will do is use something called a Maven archetype to create a new Java project there in the current directory. So then I'll say, oops, actually I got a CD into the Portland State Java Summer 2021 directory, and then I will run the create project 0. Create project 0 takes one argument, which is the your mkex user ID. So that's your cat user ID. For me, that's Whitlock. So I run that, and it does some stuff. It's doing some Maven-y things. It is creating a new project. And it says it was successful. Well, so here, and so what it did is it created a bunch of stuff, and you can see if you run a command called git status, what that tells you is what code in the checkout in under that is managed by Git has been modified. And it said that, wow, okay, what's been modified since we checked out the code is the pom.xml file, which is the top level Maven project definition. You can learn more about that in the lecture. And it also added a directory called student. And this is the directory that was created by the create project 0 script. And this is a Java project that creates a simple student application. And we're going to be working with that now. So if we go and look to see what's in that directory, it's got a couple of files. It's got one of these POM definitions, which is all about the project. It has a directory called source, which contains the source code. And it's got these two scripts that are called Maven W, which stands for the Maven wrapper. So you'll learn more about it when you watch the lecture, but Maven is a tool that builds Java projects. It takes care of compiling the code and running tests against that code and building artifacts like a jar file that contains your application that you can then run. It can do a bunch of other stuff too that you'll learn about in the Maven lecture. But it's the thing that sort of drives a lot of the work of your projects. And so when it comes to building the project, you use Maven. So then, first of all, you need to make that script executable by doing chmod plus x. If you're on Windows, you can use the .cmd, and I don't think you need to do anything to it. But then once you do that, you can run a command like maven verify, and what this will do is it'll build the project. So it first actually downloads Maven and then does some stuff with it. And then what it does is it will compile all the source code. It'll run the unit tests. It will build a jar file. It'll do all of this stuff for you. Now, when you run it, you're probably going to see that it downloads a whole heck of a lot of jars. I've already done that. And sorry, and jar it's akin to a DLL. It's a collection of code, of Java code, so a Java archive. Um, and the cool thing about Maven is that Maven knows how to download the libraries for all sorts of different things. So it'll download the framework for running your unit tests. It'll download code. When we get to the web application, there'll be code there. It also knows how to download code that I write that your project depends on. When we actually look at the code, we'll see that some of the code that's created here in this project uses code that I wrote to be able to do various things. This is the way your projects work, right? Part of what we learn about in this course is how to use someone else's code, including mine. We ran our Maven command and it was successful. I want to pause here for questions. Like a couple of them have come in here. Meanwhile, if anybody playing along at home has some questions, please ask them. See here, Madison asks, is there a way to change your user ID after running the create project shell script? There is, it's not easy. So at this point, I recommend that you just blow it away and start over again. So delete the pom.xml file, well, actually, do you need me to show you how to do that? Okay, cool. So Madison indicated it's like, I typed my name wrong. It's not what I wanted to use. So I do a git status, and this says, actually, this is a good example of what git allows you to do. Git says, here are the things that you've changed, and I want to get rid of them. So what do I want to do? I want to blow away my student directory. And I also want to get rid of the changes in my POM file. And it says use git checkout dash dash file to discard changes in the working directory. So that's what I'll do. So git checkout dash dash pom.xml. And now, oops, I have no local changes. So what the git status does is says, hey, the local changes, are the files in the same state as the last version in Git. And now I just deleted everything that was changed. So let's see here, Madison, did that all make sense? Cool, excellent. So yep, after you so you gotta delete the student directory and you have to revert with a git checkout dash dash the pom.xml. Meanwhile, I'll go through that again. I'll create the project. Oh, someone else had a question. I've downloaded Java 16, but the detected JDK version is 11.0.11. My guess is that your path is not set up. So if you do a Java dash version, so this is a question to Wei. Wei, if you do a Java dash version, what do you see? Well, I'm using Java 12. Okay. So then, while Wei is getting back to me, Dylan, are you what environment are you running Maven in? Siri, your question about what is this, your MKEX user ID, that's like what you use to log into the CS Department's Linux machines. And Bennett, yeah, I know we're going really fast. There's a lot here. This is don't worry if you got to download some other stuff and configure some stuff first. That's why I have all these instructions here in the Portland State Java Getting Started repository, so that you can then follow along at your own pace. Obviously, installing GitHub takes time. Installing Git takes time. Getting Java working takes time. All that kind of stuff. Oh, Dylan, on Windows, don't use the .sh command, please. Please use the .cmd. So on Windows, are you like using a Windows command prompt? I'm surprised it ran at all. Git bash? Huh. Try the CMD and see if it works better. It's possible the shell scripts don't work. Maven will work on. I think Maven will work on Git bash. Certainly Git will work on Git bash. It might not work with those scripts. Okay, CMD works on Git bash. Good. Okay. And if anybody is like a pro at shell scripting and wants to get that script to work under Git Bash, feel free to make a fork of this repository, fix it, and then submit a pull request. Awesome. What other things? So yeah, why it looks like you just need to configure your environment, so set your path variable so that Java is on the so that Java 16 is on the path. Okay. I'm going to make sure. Actually, I'm going to get status. Okay, we're back to this. I will run my Maven. Run my chmod again. I'll run my Maven command again to build all of that stuff, just to make sure everything can still build. Okay. So what I've done here is I've run that script, and what that script has done is it's created a Java project. As a matter of fact, I should probably show you all of the stuff that it creates. I'll do that once this is done building. It should be running Java 16. It's a little faster than this. Anyway, good. That all works well. If you that's kind of hard to read. There's a whole bunch of files that's here. Well, we looked at it in IntelliJ. I think it'll make a little more sense. But there's a whole bunch of source code that should be added. And what I want to do then is I want to put this source code under version control. And so here's how I do that. Okay, so the first thing I do is I run a command called maven clean, and what that does is it deletes all of the artifacts that were created. So when you compile Java, you get bytecode files, the .class files, it creates jar files, it deletes all of that stuff because I don't want that in version control. Only source code should be in version control. Now I'll go back and I'll look at what's changed here. I've got my POM and I've got my student. Right now, a student is an untracked file because I haven't added that to, I haven't put that under version control yet. Pom.xml was under version control because it came with that initial clone of the repository. So I will add student to the to version control. And now when I do a get status, there's a whole bunch of files there. And so it said, great, we've added a bunch of files, and oops, I need also, I guess, some of the funny things about Git. You need to say git add to add it to the change set, and now everything's in the in the change set. And now I'm going to commit these, meaning that I'm happy with these changes. I want to put them into version control. And so, sure, I'll just copy this here, I guess, and I'll say git commit, which says take these local changes, put them in version control with the comment, with a message, added source code for the student project. It tells me, okay, it added the source files for the student, or rather, it made that commit. And now if I look at status, There are no local changes because I've committed all those changes to the local repository, and it's telling me that my branch, my repository, is one commit ahead of origin main. Now, origin refers to what's on GitHub. So when I did the clone originally, I made myself a local copy of the repository. I just made a change to it, and Git is telling me, it's like, listen, that change exists in this repository, in this local repository, but it doesn't exist in the remote one. Well, I want it to exist in the remote one. So, right, this is the remote repository here. And now I want to what's called push that change up there. And so I issue a git push uh, to take the changes that I've committed locally and send them up to GitHub. And now when I refresh my GitHub page, it shows me that I just made a commit to the repository 1 minute ago, and the comment was added source files for the project, and here are all of the changes that I just made. So that is sort of a quick introduction to Git. Um, and Madison, it looks like, yeah, you're hitting some issues there. Feel free to post about that on Slack also, and I'll help engage with you after class, or maybe first thing tomorrow if you're still having problems with it, and we'll get you going. So I want to quick do a recap of what we've done so far. We've got this Getting Started repository. And this is stored in GitHub, and this allows me to share my code, or this part of the code, with all of you. And after you do kind of some magic Git stuff, you can have your own copy of the repository that, oops, what did I just do? You can have your own copy of the repository that allows you to make your own changes to it, leverage my script, and then make your own changes to it. You basically have your own source code, your own code for all of that. And then what I did was I made a local checkout, a local clone of the repository. I added, I used that create project 0 script to create a new source code project that we'll start diving into after the break. And then I made sure that it built with Maven. And then I committed the change to the local repository and pushed all the changes up to the remote repository, which you can now see in GitHub. So that's a very important fundamental first step to getting started with the course, is getting yourself a GitHub repository in which you can now build your projects, you can get all of your work done. Any questions on that before we take a little break? Okay. No questions is probably a good indication that it's time for a break. So let's take 10 minutes. I'll upload the recording right after class. Let's take a 10-minute break. I'll see you back at 7:02. Okay. Well, thanks for coming back, everybody. Just got myself a little bit of water and be as parched. I was looking, instead of going directly to IntelliJ, I know a couple of people asked about getting the CS Department's Linux machines all set up for Java. So I'll just spend a couple of minutes doing that. In the meantime, I just want to get this on my clipboard. Actually, no, I don't. Never mind. Okay. So I think most of you have logged into the machines before, and so then SSH, your user ID, and then at linux.cecs.pdx.edu. The Linux alias has a round robin machines. Will give you any Linux machine. Let's see here. Some people had mentioned Babbage. I'm on Ruby. It looks like. Well, that's neat. And so this is a Linux machine, and you have your prompt. Um, and so then, first of all, you need to configure Java. And so you want your environment to run Java 16 or Java 12. And so to do that, the easiest way to do that is to use this command called add package. This is, I think, some software that the folks at the Cat wrote a number of years ago, and this is what they use to manage software that people have asked them to install on the machines. It has a curses interface. You can use the down arrow to navigate through this. You want to either enable Java 12, or if you go down to open JDK 16, that'll give you Java 16. And by using this, what it'll do is it will configure your Unix environment to have OpenJDK on the path. And so that's the kind of the simple way to do it. I've been using these machines so long, they didn't have fancy things like add package back in my day. And so what I do is uh, I run the bash shell, and so I have my bash RC, my bash resource file that does things like configures the Java home and then puts Java home slash bin on the path. And you ought to be able to see my bash RC. I think I've made that world readable. Yes, you can. So if you want to do it that way, it works. But the add package is definitely the easier way to do it. Let add package take care of all the configuration for you, unless you really want to customize things like I do. And so then what you want is, again, when you run Java dash version, you want to say that you want to see that it's running Java 16. There's also Git on these machines, and so I mentioned earlier that one of the nice things about using GitHub is it allows you to very easily transfer code from your development machine through GitHub and then back to the CS machine. And the way you do that is pretty easy. You have to use linux.cecs. Oh, wait, yeah, cecs. I don't think linux.cs.pdxtd works anymore, or if it ever did. Um, and so then you can use you can make a git clone, again, another one of those checkouts. uh, you make another checkout, another local clone of the repository on the CS department's machine, and you'll have exactly the same source code that's up on GitHub. So we will let's see, I think I have, do I have a Git directory? I do. And so I can say git clone, and then if I go up to the top here and I copy the URL, again, I use SSH keys because I have no idea what my GitHub password is, and I make a clone there. Oops. I now have it made a clone of that repository, and now I've got that right here. I've got all the same stuff that I did before, and so now I can go back into my student directory, and as long as I chmod plus x and sorry, this makes it executable. I don't know if people know chmod. Um, then you can run your Maven w command and say Maven verify, and now this will run the same Maven command on the we'll build the source code in the same way here on the CS department's machine, and this just makes sure that that everything runs the same. It's actually quite nice, the fact that because you have source code that's in a shared repository, because you've got an automated build system, it makes it really easy to validate that yes, my code works the same on the CS department's machine as it does on mine. And this is important because when you submit your project, and more importantly, when I grade your projects, is going to be on the CS department's machine. So you got to make sure that everything works over there. Okay. And we'll see in a minute, after we make some changes locally, we'll see how we can transfer those changes over to our checkout on the CS department's machines. So anyway, I just wanted to show off all that. Oops. Okay. I'm gonna log out of the CS department's machines. Now, we have created the source code. We have like the skeleton project for the student application, and now we want to work with those files. Now they're text files, right? Java source code is just text, and so you could use any text editor, conceivably, right? You could use Emacs, you could use VI, you could use Notepad. I don't know why you'd want to, right? Because it's just text that you're editing, and then you can build things from the command line, and that works, but it's kind of slow and it's not interactive. And if you typo something, you don't find out about it until you run the build, and so then when it comes to writing software at scale and big things, if you want to go quickly, it helps to have tools to make it go faster, right? It's why we have tools, so that you can go faster, you can be more efficient, so you can do it's like why you have like a backhoe, because it's like digging ditches is slow and painful and everything. No, we want to have tools to literally do the heavy lifting in that case. And so then the tool that we use, our backhoe, and this is a terrible analogy, is a thing called IntelliJ. So IntelliJ is an integrated development environment, an IDE, that lets you edit Java code really easy and really nicely. And so IntelliJ, there's a link to downloading it here. They do have. Oh, I don't have a. They do have student licensing. It's on the website here. Let's see here. Oh yeah, academic licensing. And so then again, if you've got a .edu email, you can get like a 30-day license, or we can also apply for an academic license. It's free. And then you can run IntelliJ. And so after you've installed it, and after you've installed it and it's running, you want to open up your you want to open up you want to edit your project in IntelliJ. So you click the open. Oops. And let's find my Git. No, actually, that's not it. I want the PSU directory. Git Portland State Java Summer 2021, and open the pom.xml. This is the top level pom.xml for the project. And so, and the pom.xml is a Maven configuration file. It's the thing that talks about all the Maven stuff. And IntelliJ knows about Maven. So when you open that file in IntelliJ, it'll be like, oh, wait a second. Clippy comes up and says, looks like you're trying to open up a project. And the answer is, yes, I am. And so then you click open as project. And then what IntelliJ does is it goes through and analyzes that Maven project, and then creates an IntelliJ project, an IntelliJ view um, of all of your source code, and it knows things like which directories contain plain old source code, which directories contain sub projects. It's doing some analysis right now, and it says importing. Looking down here at the bottom, it said importing Maven projects, and it's figuring everything out about your project. That's the nice thing about Maven; it provides conventions that tools like IntelliJ can follow to make more sense of your source code. So over here on the left, you've got this project view, and you can. These are these are the files that are in the directory, right? So if you look here, it's the same stuff here. You've got all these shell scripts, all of this stuff. But now you can navigate into them, and you can look at the source code. And so then IntelliJ knows that the source code in this student directory, student is bold here because it's a sub project. There's a student project within the larger Portland State Java Summer 2021 project. And underneath that, in the source directory, the convention that files that are in the source main Java directory are the source code for your project, the primary sources there. And IntelliJ knows this. And then I've got this student file right here. Now this is the first Java code that we've seen. So sorry, it's been an hour hour and 45 minutes. How long have I been talking? Forever. And we're finally seeing some Java code. So here we go. And just to walk you through, every Java class is in a package, and the name of the package corresponds to, well, like your organization. So for me, all the code that is in this course is an EDU PDX CS410J. And when I created this project, remember I put in, when I did the create project 0, I said create project 0 Whitlock. Well, that puts it in a sub package that's my package. And if you go and look at your source code, it'll be in one there. There's the student class that is the the main code that we're running with, and it's got a constructor, it's got some methods, all sorts of stuff. It's got some Java doc. We'll see all this stuff in the next couple of weeks. But a couple of interesting things that I want to point out here. So here we have this class student. So student is is the class that we're declaring here. It extends, so it is a subclass of human. Now, human, if we look at it, is actually that's a piece of code that I wrote that's not part of this source code checkout. So when we go and look at it, that's interesting. Um, because of because all of I wrote a bunch of code and deployed it off to the central Maven repository. When you built your project, it downloaded that code, and it downloaded the source code for it also, because I published the source code, and now you can see it in IntelliJ. So this is code that comes from me. You can't change it. You can tell because it has a little lock here next to the icon. But you can see my source code, and so then you can understand what it does, and you can see the comments in it, all sorts of good stuff like that. And this is what a good IDE allows you to do. It allows you to explore the code while you're compiling it, and then we'll see later you can explore it at runtime also. But it helps you make sense of things, and it helps you navigate the code really easily. So now that we're looking at the source code, let's talk about this Project Zero a little bit more. So let's talk about this. So when I first started teaching the course, I had this Project Zero, which was really meant to get started. And after a couple of years, I realized that no, it's much better for me to go through this with the students instead of just assigning it to you and having you figure it out on your own. So the whole idea is that a very simple class to learn about just how to work with Java. So you write a student class that is a subclass of human, which we actually talk about in the lectures a little bit. And the whole idea here is that it's your first experience working with someone else's code. You get to learn about inheritance a little bit, and then you can also and then you also learn about working with the command line. The first couple of projects in this class are going to be command line projects, because you're focusing on other things, not the user interface. When you get to Android, then the user interface gets more interesting. So what that create project zero script does is it creates this source code right here, and I've just duplicated it here so it's easier to see in the assignment. Uh, there's some interesting things about a student. Every student has a name. Every student takes a number of classes, and so then classes is an array list of string. Every student also has a GPA, which is represented as a double, and then a string that represents the student's gender. And the valid values, or the allowed values of gender are lowercase male, are case insensitive, male, female, or other. And then what the first thing that this does is that invokes the superconstructor inherited from human. This class has some methods, right? Methods define the behavior of the object or the class. All students say this class is too much work. So this is a comment here that describes what the says method does. Its current implementation is to throw an unsupported operation exception because it hasn't been implemented yet. That's all part of the assignment. There is a toString method that describes the student, again, not implemented yet. And then a main program that parses the arguments from the command line, creates a student object, and prints a description of the student to standard out by invoking the toString method. So ultimately, this talks a little bit about the Maven. We've already seen it. You run Maven Verify. What Maven Verify does is it runs your project, your Maven project, through its entire life cycle, builds the source code, runs the tests, builds the jar file. And we'll see what that is in a minute. Runs integration tests, and then verifies that everything passed. You can run this main program via what's called an executable jar file. Now, that jar file is that Java archive. It contains all of the compiled bytecode, the compiled class files for the program, for the application. And if you invoke java-jar and give it the name of the, oops, this isn't accurate anymore. If you give it the name of the jar file that's created when you run Maven package, the package phase of Maven, then it should, and with these inputs, Dave, Mail 3.64, algorithms, operating systems in Java, it should print out the following. This is ultimately what we want the program to do. We want the program to say Dave has a GPA of 3.64, is taking 3 classes, algorithms, operating systems, and Java. Some questions have come in. Question: shouldn't students constructor take gender, seeing as it's a student-specific property? It does. So maybe I'm not too sure. So the last parameter to the constructor is the gender. So I'm not. Humans, not student. That's a good question. You know what? I just chose to model humans as genderless. You're right. We probably want to refactor the the gender property up into human. That's a very good question. Um, is the edu version of IntelliJ free with an MKEX account? I don't believe there's any. Well, I don't know. I don't know if Portland State or if MCAPS has a site license for IntelliJ. Might want to reach out to the cat. I do know that I use I use my pdx.edu email and that's fine. Yeah. Okay, good. People seem to know that. Question about exception handling. We'll see some examples of it. It's also covered in the lecture. Let's see here. We'll be supposed to know that very well before we begin. I don't know about very well. I mean, go back and review some of the information in the lectures um, and I think we'll see though through the through the development how to handle exceptions and try catches and when to use exceptions and when to use checked and unchecked exceptions. Um, let's see here. When we code our projects, how much implementation freedom will we have? Well, I do not look. So with 60 students, I don't have time to look at your code. The graders don't have time to look at your code. So for better or for worse, you can code however you want. It's got to work though. So you have freedom to write however you want as long as it works. And of course, you don't have freedom to copy someone else's code. But really, those are the primary constraints on your code. But I do encourage you, and we'll see examples of it through the course, to write clean code that is well factored, that is easy to read, that has good names, methods that are short, etc., etc. We'll see lots of examples of that. Indent length. Again, I don't care about it, and I'm not going to get into any sort of holy war about spaces, tabs, 2, 4, 3, prime numbers. We ain't got time for that. MKEX should have Java 12 and Java 16. So actually Java 12 or above is what I'm looking for, Michael. And I think we saw, I showed an example a little while ago to how to use the add package to configure things. So no, Java 11 is not sufficient for this course. Okay, oh, thanks. Okay. What about efficient code in terms of runtime? Just briefly, it's not the primary goal of this course. Here we're learning about functionality, but of course, when we write code for real, you need to consider the how well it runs. I guess I will say this: get it working first, and then get it working fast, and we'll see how test-driven development and having automated tests will let you optimize your code confidently, because you'll know that it still provides the functionality that you want, and then you'll have an opportunity to make it run faster. Okay. Thanks for helping everybody get set up with the add package and everything like that. So I want to reiterate what I said before, and I'll show you what's going on here. So I'll go back to the source code. I'll go to the student directory. I already ran Maven verify, and verify also runs Maven package. So if I look in the target directory, oh, maybe I didn't. Huh. How many times do I have to build this thing? Oh, probably because I cleaned it before I. Actually, I'll just run Maven package. Be a little faster. Oops. What? Oh, am I? No, Okay, that was weird. I guess I didn't do that. Okay. Maven W package. So what package does is sort of the beginning of the phases. It'll compile the source code. It will run the unit tests. It will build the package, but it won't then run the integration tests and verify that they ran successfully. For right now, that's fine. So you can see it's running the tests there. It's doing some other stuff. It's making a jar file. Again, that jar file is the contains all of the class files and is an executable jar. And now the moment of truth. Student. Oh, and the version. Okay, so this is there's a typo here. I used to have a version number that was like summer 2020. Gosh, that's way out of date. It should be 2021 first of all. This term I switched to semantic versioning, and I can tell you why in a little while. But semantic versioning is basically like major dot minor dot patch or dot micro or whatever. No good. And so I ran that and it prints missing command line arguments because the main method, all it does right now is it prints missing command line arguments. So I just ran my program using this. So you say Java, which invokes the Java virtual machine, dash jar, it tells the tells the JVM that I'm running running an executable jar, and then you give it the name of the jar file and it invokes the main method. So right now, it says missing command line arguments, but ultimately what we wanted to say is Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. So ultimately, that's what we're going to have to implement in this class. Sorry, well, in this student project in the student class. Now, the student project not only has the source code, but it also has tests, also has unit tests. Now we'll do another interactive thing. React using Zoom. Who here has written unit tests? A couple of people, but maybe only a couple of people. Okay. Good to know. You're going to see a lot of unit tests, a lot of automated tests in this course. One of the things I've learned over my career is the value of validating your assumptions. And whether this is assumptions about your code, assumptions about life, assumptions about your spouse, right? You want to make sure that you have clarity and that you can demonstrate it's like, oh, yes, I think this is true. Oh, and it's actually true. And that's what tests give you. Tests let you verify that your code works the way you think it ought to. Uh, and there's power in this. There's power in that you can go. It helps you go fast. It helps you make a change and then validate that you haven't broken anything. It gives you confidence that like what you wrote 2 weeks ago, you've probably completely forgotten about. It still works. There's a lot in that, as opposed to like the uncertainty of like, well, I don't think I've broken anything, or the hubris of like, well, I couldn't have possibly broken anything. No, this actually tells you. And there's just a lot of good things that can happen because of that. So here I have a simple test in in Java, and we use the JUnit framework in this course. And what JUnit allows you to do is have a class, and this one's named Student Test. By convention, all the test classes end in test. It's got a method. It said student named Pat is named Pat. When I write my method names, they tend to be pretty long because I want something that's descriptive and something that I want to, when it fails, I'm like, oh yeah, that's what it was doing, that's what failed. And then oops. And the way you know this is a test method is that it's annotated with this at test. And then the code that's here in the method, it runs a test. And so unit tests, and I'll talk about this again. When I have a test, when I have an assumption, I think of it in three parts: as given, when, then. So given that I have some condition, right? I've done some setup, I've established some state. When I do something, then I expect some result. I use this pattern over and over again when I'm specifying behavior that I expect to be true. So given some state, when I do something, I expect something to be true. Um, uh, so here, given that I've got the name Pat, when I create a new student with that name, and I give it up, sorry, with that name, I give it a bunch of other stuff just to make it compile. I'm going to assert that when I call the getName method on my Pat object, the value returned by getName is equal to my variable name. Now, this assert that syntax is part of a library called Hamcrest, which is an anagram of matchers, that I talk about in the JUnit lecture. If you've done Java before, you probably don't need to do a Java review. Maven, you should look at it. But the JUnit lecture is really important. I really encourage you to go through and watch that because it'll give you an introduction to unit testing. It'll give you an introduction to the JUnit framework and their APIs, and because you'll be using it a lot. I'll talk more about it next week, but unit testing is a really essential part of this course and something that I want you to get a lot of experience with. And so then, please get used to it. Oh, and all this conversation going by, it's really important that it's Maven W, not Maven. It's that Maven wrapper script that you need to make executable that you need to run. That way you don't need to install Maven separately. So in IntelliJ, it's smart enough to know that this is a test class and this is a test method. And then over here in the gutter, it gives you a couple of icons to do things like run this test method or run all of the methods in this test class. And so when I click on this thing, and there's also a keyboard shortcut for it, what it does is it gives you an option. It's like, do you just want to run this test? Do you want to debug it? We'll see debugging later. Do you want to run with code coverage, whatever. But I'm just going to plain old run it. So I'll run it. And what IntelliJ does is it builds the entire project. It compiles the source code. It gets everything ready to run. And then it'll run your unit tests and then tell you what happened when they ran. So it's doing all sorts of good stuff. It's running it, and it said, great, my test results. I had here in my student test, I had a student name path, green check marks all around because everything passed. Which means that when, that this assertion statement was true, that when I call the getName method on Pat is equal to name. And getName, and sorry, if you hold down on a Macintosh's command and Windows and Linux, it's control, you can navigate to the getName method just by holding down that and clicking on it. Oh, interesting. And it brings you to the parent class. So that's how you run unit tests. We can actually change this a little bit. What if we can make it fail just to see what it's like if we then said, oh, I'm going to assert that when I call pat.getName, it should equal to the name with two X's after it. Well, let's see what happens. We'll run that test again. Oh, that's an interesting statement. A common job that you get out of college is being a tester. I don't know how common it is, but the way I look at it is that a tester isn't a separate role anymore. There are people they're great QA engineers. I work with them. They provide a tremendous amount of value because they understand the big picture, but they're not the same as a tester. These days, everybody writes tests, especially the person that writes the code in the first place. As a matter of fact, I don't want anybody finding my bugs. I want to find my own bugs before anybody else does. And that's why I write tests. I write tests to make sure that I can be very confident that my code works because, I don't know, maybe I have a fragile ego, but I don't want people to find bugs in my code. I instead want them to ask me, hey, can you add a little bit more? Can we change this behavior? We thought it was the right one, but maybe we wanted a little bit different. To me, that's much more gratifying than having someone realize, like, oh, I made a mistake. I changed the code so that it would fail, and sure enough, it did. It gets a yellow X next to it, and it gives me information saying, hey, I expected to see pat XX, which would be that expression right there, but instead I got pat. And so now it's failing. You can even, IntelliJ is nice enough to actually give you like a nice side-by-side comparison between stuff. And that's kind of cool when you're looking to compare strings. It also underlines the thing that failed in orange, and you hover over it, and even tells it right. I mean, it's all sorts of great stuff. A good old IntelliJ. One more thing I wanted to point out here. Over here in the gutter, you notice that there's this blue highlight. This highlights a line of source code that has changed with regards to what's in the GitHub repository. So someone asked about, hey, is there integration between GitHub and IntelliJ? The answer is yes, and it's really nice. We'll be seeing lots of examples of it as we start developing this application more. In the meantime, I want to get rid of this code. It's not something I want. So what I can do is I can click on this, and I can use this revert button that rolls back the lines right there. This is what's in source code. I can then run my test again, and it ought to pass. Oh, good, it does. So that's a quick introduction to unit testing. I want to dive into test-driven development. Before I do that, I wanted to open up the floor to any questions about about what you've seen in the last couple of minutes.
What I can think of is sort of just continuing from what I mentioned earlier in comments about the exception handling, which is, are we going to incorporate exception handling into unit tests as well?
Yes, we will eventually see an example of that, but it's a very good question. Exceptions are all part of an API, are all part of the contract that a method provides. And so then just the same way that you want to test that the return value of a method is what is expected, or some other side effect of invoking a method is expected, you also want to test that an exception is thrown under the conditions that you expect. So of course, you don't necessarily want to test for null pointer exceptions and things like that, but the answer, generally speaking, is yes, and we'll see how to how to handle that as we continue to develop the student test application.
Thanks.
Question. Yeah. Okay. Okay. Let me now. Now we're gonna we're gonna have a guest lecturer. So I mentioned test-driven development. Unit testing became really popular around the turn of the century, well, rather it started becoming popular around the turn of the century, and it got so popular, in fact, that a lot of people realized that, wow, there's a lot of benefit in writing your test first so that it fails, then making it pass, and that way you've got, you know that your code is always doing exactly what it says it's supposed to. And so this introduced the concept of test-driven development. And so what I'm going to do now is I'm going to share a video by Bob Martin, by Uncle Bob Martin, all about test-driven development. I am going to change my sharing configuration here. Oh, here we go. Share sound and optimize for video clip. I'm going to play. It's a little 5-minute video. I warn you, it's a little cheesy, but let me know if you cannot hear the audio. No audio yet. He'll start talking.
Oh, it's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right. What test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Happy coding, everybody. Oh, you can see the Zoom interface bar and everything. Oh, sorry about that. and yes, you didn't miss much. That's interesting. So like when I share, optimize for video. Wait a second, what is it doing? I don't know. I will stop sharing sound and stop optimizing video clip. Yeah. Uh, so, uh, what did you observe there? So, other than the hat and everything like that, what were some of the things that you saw Uncle Bob doing, and what do you think was important? What was meaningful? What did you take away from that video that we just watched?
Well, one thing that stood out was that basically one thing that really stood out was that he wrote the unit test for the gutter game first, and then wrote the score function that he was trying to test. So I guess basically, I suppose part of it was that a key part of of test-driven development is not just writing tests soon after writing functions, but actually possibly writing them like in tandem with functions.
Yes, and actually, um, in like the most in purest case, you write them before, right? That's what we saw him do, right? He wrote the code and he started, okay, I sketched out the test, this is what I want to do, and it's like, oh right, like the roll method doesn't exist, and then I'll go create it. Oh, the score method doesn't exist, I'll go create it. It seems almost backwards. It's really the way I wasn't taught right to write code like that. No, you write all your code first and then you go through tests afterwards. That's bad. Or rather, it's you get much better rapid feedback, and you can work in smaller batches and change directions and explore and learn things more quickly that way, if you have tested to make sure that all of your previous assumptions are still true. Oh, a couple of observations in chat. So he created tests for things that didn't exist. Yep, exactly. You write the test first, and then you code it into existence. Write first, then code. Slow but productive. Yes. Although I've found that it's way faster to write a small test, small code than like all of your code and then trying to remember all of your tests. So, because boy, after the fact, trying to go figure out, it's like, oh, what should I test or anything? That's just a cognitive load because you have to think about the whole big picture and keep the whole big thing in your mind as opposed to just working on little things at a time. Oh, good observation. I think it's a good idea to go in with a rough test plan at least. I would agree. And that's when, like what I do is I like to sketch out those given when then scenarios to sort of understand, hey, what is it that I need to test, and what do I need to set up, and what exactly do I need to do? To sort of have that in my head, or maybe have it on a piece of paper, especially if I have something I don't want to forget. Yep, I'll write it down.
I have a short question.
Yeah.
Is there a way to set up an IDE such that basically so he made a new unit test, right? And it tested the score function. Is there a way to set up an IDE so that basically it keeps track of the tests that have run and passed, and keeping that separate from new tests that they haven't run before? So like, for example, would you have to run all the other tests to test that other one?
You don't have to, and it's true. Like what when I write, and we'll see this. Well, I'm writing a single test and I get that working, and then I need to. It was a whole red green refactor thing where it's like you write a test that fails, and then you make it pass, and you look for opportunities to refactor. Now, when you refactor, you might change code that's impacted by multiple tests, and so then. I don't always run all my complete test suite after every change, but ideally what you want to be able to do is quickly verify things. And really, you can write dozens of unit tests that run in under a second if they're just exercising a little bit of functionality, and so then it's all about feedback. And so the more often you run more of your tests, the more feedback that you get. So of course there's a balance there, but there are a couple of rules of thumb that I always follow is that don't go more than 5 minutes without running a large suite of unit tests, because you never know what you're going to break, right? And my experience is has been that, oh wow, I make some little change over here and great, these tests work. Oh, now I've broken something over there, oops. But you find it really quickly if you run all of your tests.
Mhm.
um So someone asked about hey, what is a gutter game? What is bowling and all of this stuff? That is a good question, not because that specific question is like really great, but it shows the importance of understanding the domain that you're testing and understanding the problem that you're trying to solve and sort of the what of the solution, not sort of the how, but like here's what I want to provide. So yes, that's an important thing when you are testing and when you are coding, that you use terminology, nomenclature, words that are appropriate to the problem that you're looking to solve. Great observations. Okay. I want to do a little bit of test-driven development, but I see that it's almost 8 o'clock, and so we still got a lot more to cover tonight. Um, so this just to to reiterate, we're working on our student class. Ultimately, we want to say, hey, listen, when I invoke the program with this information, with these command line arguments, I get this output. Now, this is ultimately what I want my program to do. And so like the first test that I'm going to write, just so I understand the problem, I'm going to write a test that that validates this. Now I know it's going to fail, but it's okay. I still want to write it anyway. So here in my student test, I'm going to want a new test method. It doesn't need to be public anymore. Void, I'm going to call it Dave student from assignment. And here, I'm going to have a student named Dave, and this is a new student. Actually, I forget the order of everything, but eventually what I'm going to want to say is I'm going to say assert that, oops, come on, assert that Dave.toString equals this thing right here. So I'm going to copy and paste that in. Great, that's all that. Sorry, I'm moving the chat window around so I can see. There you go, make it smaller. Actually, that looks pretty good. Oh, there's no new line there. Operating systems. Okay, cool. So let's see here. The first thing is the student's name, and that's Dave, and then the classes. I'm going to create a variable for that. Okay, I'm using IntelliJ. You're gonna see, this is what I do a lot in the class. I'm sitting here coding. I'm saying things to myself, sort of giving you my my internal narrative, um, and I use the keyboard shortcuts a lot because I've been using this tool a long time. And so then if I do something and you're like, what the hell did you just do? Please call it out. I'll also try to explain what I do along the way. I also have this IntelliJ plugin that puts these bubbles at the bottom of the screen when I hit keyboard combinations. So I just used Alt Enter. And what that does is that says, hey, there's an error. Here are some suggested corrections. And here I want to create a local variable called classes. And so it creates that local variable for me, which is super nice. And I'll make that a new array list. I started typing array and it popped up, hey, did you mean array list? And I said yes, and I hit return to accept that. I hit Command P on the Mac to tell me what the parameters are. The next thing is the double, is the GPA, that's 3.64. And the gender is male. So this is like the ultimate test case for the functionality in the student class. So when I give an example like this, when I give a student named Dave that takes those classes, oops, I'm sorry, the classes isn't populated yet. Classes.add 3 classes is algorithms, operating systems, so algorithms. The second one is classes.add operating systems and Java. Oh, I think I have 2 spaces. I want 2 spaces after my period. He says this class is too much work. Okay. Okay, so now I've written my class, and everything compiles, and that's nice. So there's not that part of the of the red. I'm just going to like space it out a little bit so it's easier to read. Now, when I run this, however, it builds it, and it fails, miserably, because it says not supported operation, unsupported operation not implemented yet. Well, that is true. Let's take a look at what it's telling me. So this is a stack trace in Java. So when an assertion fails in a unit test, it throws an exception, and it's a assertion failed exception or something, and then IntelliJ knows how to interpret that. Here, IntelliJ is running the Java code, right? It runs the Java code, it fails with an exception, and then it presents what's called a stack trace, which tells you which line of code was being invoked when the exception was thrown. So in this case, it starts out with this line from the lines 34 from the student test. When you click on it, it goes to that line and it highlights, it's a two-string method that's being called. You click on this line, and this is then the source code for the two-string method. And so it throws this unsupported operation exception. So this tells me what I sort of already knew. It's not implemented yet. Okay, now I gotta get to work implementing it, but I don't want to implement everything. I want to start working in small pieces. So I still like this test. This is a good test, but it's not one that I want to run. And so I could do something like comment out the code here because I know it's not going to run. I don't want to do that though, because if I go in and I change the names of things, I want this code to be renamed also. I still want it to be compiled. I still want to make sure it can be compiled. I just don't want the test to be run. And so the way you do that is that you say sorry, it's not at ignore anymore. It's at disabled. Yes, at disabled from the API, which means that it's still a valid test. It's just not going to be run as part of the whole suite. So now if I go and I run all the classes here, or all the test methods in the class, it will note, it'll run the student named Pat as Pat, and then it'll say, oh wait, Dave's student from assignment, this is disabled. That's good. Okay, so I've added this test here.
So I just noticed that someone has had their hand up virtually.
Oh, I am sorry. I am not looking at the participants right now. I apologize for not seeing that. Yes, Harsha. Yes. Please feel free to ask your question.
No, I'm sorry. It was from the previous. I also to say the same thing. Your Zoom controls are in the video.
Sorry.
It's just sticking like that. So I
Okay.
don't know how to do that. So
Okay. Well, and yeah, and in the future, feel free to also to come off mute. Don't worry, I can always rewind Uncle Bob. Thank you. I'll keep the participants up. I'm on my laptop screen. I don't have a tremendous amount of real estate. Actually, I might get some more if I hid this over here. Here we go. Okay, so I've implemented a test, and I want to take a little bit of a detour here. Okay, so yeah, I think I got enough time. I wrote some code, and okay, I wrote some code. It didn't pass, but it's okay. I disabled it, and so now everything's working, and I'm happy with this code. This code is doing good stuff, and I want to commit it to Git. I want to commit this code to my source code, so that's there. And so if I need to roll back to it, it's there, and so I can also share it with other places. And so what I'm gonna do is let's take a look at some of IntelliJ's functionality for managing for using Git. So it has good integration. So I open up this Git tab down here, and it's telling me that here in my change list, the files that have changed is studenttest.java. And sure enough, I mean, it's got this big green bar here, which means the code was added. And now what I can do is I can click on this, and I can either do a right click to look at the menu, or I can let's see here. I think it's this button right here. Yeah, commit. So what this allows you to do is commit the change to GitHub. And just to reinforce the point, if I do a git status here from my student directory, sure enough, it says that my student test file has changed. Okay, good. But I'm working in GitHub right now. Sorry, I'm working in IntelliJ right now, so I can commit that and using Command K. And what it allows me, it shows me here's all the files that have changed, and it allows me to put in a commit message, and wrote a disabled unit test. Well, wrote a unit test that validates the end-to-end functionality of the student.toString method. Let's see, a quick question from Lee. I'm not seeing default change list or local changes in my IntelliJ. Have you made any changes? Because if you haven't made any changes to your source code, you might not see them. I don't know. Oh, you have? Okay. Let's see here. Checkouts under Git. So I don't know off the top of my head what we're seeing there. Let me commit this, and then maybe we can dive into that a little bit. So wrote a unit test that validates the end-to-end functionality of SU method. The test is disabled because it will be a while before it passes. Let's see here. You can have it do all sorts of stuff before a commit. I don't have to-dos. I'm curious about what it finds when it analyzes the code. And so then I click commit. And what that does is that commits it to the local repository. So now as there are no changes there, and if I run git status again, there are no changes. It does say, though, that, hey, you've got a local commit that you haven't pushed to GitHub yet. Okay, well, I can do that through IntelliJ also. I could have done it as part of that commit dialog, but then you can also go up under Git, and you can say push, and what that does is then it will push it. By the way, can you see the zoom controls now? No. Okay, that's good. Now I can push the changes from my local repository up to GitHub. Oops. And now I'm going to go back to my GitHub repository. And this is the summer one. I am going to refresh. Okay, and I just just made this change to write a unit test there. So I just checked in some code. Now I can also go back. Actually, you know what I should have done is before I commit, I should have also run the test from the command line, and so that you can do that with Maven. Oops, Maven. Sorry, there we go. Maven W. You can just say test. Actually, from the test phase. And so now that will build things with Maven. It ought to be the same as what it is in IntelliJ, but it lets you know for sure. Okay, good. It ran. Yeah, it said that one was skipped. Yep. And that there were no failures. That's cool. So everything's nice there. One last thing I want to show you. Let's log back in to the CS department's machines. And I had a clone of my repository there. Important State Java Summer 2021. Here, I've got all of this. I can do a git pull here. And so what pull does is it takes all the latest changes from GitHub and integrates them into my local checkout, my local clone. It asks me for my password. Oops. There we go. And it pulled down a change to student test. Ding. And now I can go into the student directory and run the tests again, and then we'll see that the second test is run now. It'll recompile the source code, and then it'll run the tests. Yep, there it is. 2 tests were run, 1 was skipped. So that's how you can move code in between your local development machine through GitHub to the CS department's machines. And I like doing this because Git does the heavy lifting. You don't need to worry about like, hey, was rsync going to work and everything like that. Git is the one that takes care of making sure that everything is there. And so, yeah, question. So we will push code from our local machine and pull it on the PSU machine and test code on PSU machine. Yes, I recommend that workflow highly. I think that'll be very effective for you. Okay. So a couple minutes ago, some people were struggling with local changes in IntelliJ. Are you still seeing that? If so, you might need to, let's see here. Okay, so a couple people were saying yes, and then, okay, but then maybe it took a little while. Okay, so some people, it looks like it got fixed for them. It used to be, and you know what? One of the problems is that like my IntelliJ environment's been around for years, and I'm running the latest version and everything. But lots of things have been, just sort of customized and work. When it's a fresh new installation, there might need to do things that sort of initialize uh, things and stuff like that. So, um, boy, there used to be like a menu item to like enable version control, which I don't think it has anymore. But maybe for a brand new installation, you'll have to do something like that. So yeah, for anybody who is still struggling, maybe just try a couple of things. And again, guys, excuse me. Reach out on Slack. And it's probably easier for us to have a real time or at least a sort of persistent conversation there. Okay. Okay, let's write one more unit test and then it'll be time for something a little bit different. Okay, so I wrote this one. This is like the complete end to end. I want to do something a little bit more simple. I've already validated that the student name Pat is work, so get name seems to work. Let's oh, I know. Let's write another test for um let's test that uh the toString method contains the student name. So I will, um, you know what? I want to create that. I'm just going to have that Dave student again. So here's what I'm going to do. You saw that one of the things that Uncle Bob did was he refactored the code, and this is when you've got uh, code in one form, you want to change into something else. Maybe you have duplicate code that you want to coalesce into one place. In this case, I want to be able to recreate this Dave student again. And what I'm going to do then is extract the logic for creating Dave into its own method. So I'm going to highlight this code, and I'm going to go into the refactor menu, and I'm going to say extract method. And now this creates a new Java method, and I'm going to call it getDave. There we go. And can you change the method signature? Okay. Thanks, LJ. Great. And so now I've got this get Dave method. I don't need this. It's highlighting yellow because it says, oh, local variable is redundant. That's awesome. I want to inline that variable, which now gets rid of the variable and just returns that value. So inlining is another kind of refactoring where you take an expression and that's assigned to a variable and then just get rid of the variable and use it there instead. Okay. So now I did that, and now I want to have my student named Dave again, and I will say get Dave. And now I want to assert that Dave, oops, come on, Dave dot toString contains string, no. I'm going to use the magical Alt Enter. And contain string, okay, in the JUnit lecture, you'll learn about the Hamcrest API, which provides all these really nice matchers. So I want to import that static method. It knows what it is. I want to say matchers.contain string. And I want, well, to have it return the string, it returns the string Dave. Yeah. Now I'm going to run this method. I'm going to start using keyboard shortcuts. So I'm going to say Control Shift F10. That's what I use. I guess there's other stuff. It's going to run it, and it fails. It fails because, oh yeah, when you invoke toString, it throws not implemented yet. Okay, so what do I need to do to implement this method? create my student named Dave, and I want its toString method to return the string Dave.
Repeat the question, please.
Sure. I now have a failing unit test. I have my red hat on, and it says it's failing because the toString method currently throws unsupported operation exception. Yep, that
Okay.
would do it. But now what do I need to do to fix this?
Mm-hmm. And you're testing. Are you testing for the "this class is too much work" string?
Nope, I'm testing to that the toString contains the student name.
Okay, so yeah, we should return the name data field, right?
Yeah. So, and I'm seeing similar answers here. It's like we need to return the name from toString. You have toString return something other than an error. Yes. And so, okay, we need it to have toString return the name. Oh, there's a getName method. Cool. Okay, we'll use that. And I know this isn't complete right now, but that's okay, right? We're taking we're writing just enough code so that the test passes. And that's another tenet of test-driven development, that you work in very small batches, and the only code you write, the only purpose of the code that you write is to make your test pass. So you have to resist the urge, like, oh, I'll implement a whole bunch of stuff. Don't do that, because you'll get ahead of yourself. You'll write code, and it's not tested yet, and so you don't know if it really works. So, okay, good. So now when we run when we call toString, it'll return the name, and that should be Dave, right? So let's run it. So I'm rerunning that. It rebuilds it, and it passes. Sweet. We've got a test that passed. Now we've got the green. And now looking for opportunities to refactor. I don't see any, and I think that the test is already pretty well refactored. Anybody else see an opportunity for refactoring? Yeah, I don't. Okay. Okay, well, let's commit these changes. We've got 2 changes. We made a small change to student and added a new test there. And so start using some keyboard shortcuts again. So Command K to commit. And let's see here. Well, my comment is the student toString now includes the name of the student. And when I commit, I can also say commit and push. So this in one fell swoop is that. And we'll both commit it to the local repository and allow you to push it remotely. Question came in, where does contain string come from? Yes, good question. Contain string is from the matchers class. The matchers class is part of the Hamcrest API, right? Yeah, exactly. And you'll learn more about that in the JUnit lecture. Okay. A couple things, there's a whole bunch more test-driven development that that we can do. I want to step away though to do something a little something else before we cover the projects and stuff. It's time to go into breakout rooms, and there is, and let me let's see here. Sorry, somewhere here. Yeah, I have. Just a moment. Let's see here. It's here. Yes. Let me move this to another window. This one right here. Excellent. Okay. Um, I want to hear about your experiences with remote learning. Uh, you know, we've been doing this for, depending on how long you've been at PSU, up to, gosh, seems like a year and a quarter or whatever. 5 terms. There's the 5th term, I guess, of being remote. And I want to know what's been effective for you, what's been ineffective, and the ideas that you have for making our class effective. So here's what I'd like you to do. I want to spend. Let's spend 5 minutes thinking on our own. to answer these questions. So you can, make a piece of paper or in a document there on your computer. Think about your own answers. And then what I'm going to do is put you in breakout rooms, groups of 4. And I want you to share your answers with each other. And think about some similarities, some differences. Talk about some of the pros and cons. Maybe for one particular thing, somebody thought in the group thinks was really ineffective. Maybe it's not so effective. Actually, I'm going to do groups of with 49. Do groups of 6. Um, and Yeah. And then what we'll do is we'll reconvene, and I'll ask for a volunteer from each group to contribute what they found to be effective, ineffective, and ideas. And I'm doing this so that first of all you have a chance to talk with each other. Second of all, so I can go get some more water. And but really what I want to what I want to learn is now that you've been doing this so long, really what are the things that I can do as the facilitator of our time together to make sure that you are having an effective and engaging experience in the course. So again, effective, ineffective, and ideas. I'll post these in the chat. Yep, that'll work. And I'll pause the recording for a couple of minutes, let you think on your own, and then I will send everybody into breakout rooms. And then we'll have, I don't know, let's say 7 or so minutes in the breakout room. Maybe 10 is probably better if it's going to be 6 people in there. And then we'll reconvene. So this will be, a 20-25 minute activity. Any questions before you have 5 minutes to think about the answers to these questions? It's a little loud. Okay, excellent. I'm really curious to hear what you've all been talking about. I'm going to go through the rooms in order and ask for a representative. I hope you figured out who it was amongst yourselves before you came back. And so I will remind everybody that when you come out of a breakout room, Zoom puts you on mute. And so then if you're going to be talking shortly, please unmute yourself. Let's start out with room 1. With representative from room 1, please talk about, please come off mute and tell us some of the things that you found to be effective, ineffective when remote learning, and then any ideas that your group had for making our class more effective.
How do we tell who was in remote?
Yes.
Yeah, I don't remember what our number was,
Fair
but
enough.
I think that was
Same.
up.
It was yeah, Matthew. It was you.
Ours was 2, Andrew.
Okay. I was just
Okay. What has been effective in your remote learning classes? Can you hear me, by the way?
Sound great.
yes.
Okay. What has been effective in your remote learning classes? So we found that using Slack was a lifesaver, and especially for group discussions, or if you wanted to refer back to maybe some student had already asked a question that you were looking for the answer to. Another thing is Discord channels as well. We all really like Discord. In fact, I just made a Discord server, and I'm just going to post that invite there in the chat if anybody wants to join.
Can you tell me why I'm not familiar with Discord? I suppose I could ask my kids. Face feel old. So what was it about Discord that was awesome?
So Discord is great because for one thing, Slack. I'm getting a bunch of notifications now. Slack limits the conversation to like a week or so, whereas Discord, you can scroll all the way up to the beginning of the entire conversation being started, which is nice. Another thing is that Discord is just one big chat instead of doing like threads with like sub threads. So it's just like one big chat that everybody can engage in at the same time. And it just kind of has more of like a chat room feel to it. So if maybe there's just a couple people on, then they're all seeing the same thing, whether or not they're included in the conversation or not.
Cool.
So,
Yeah. What was some things that have been ineffective? What hasn't worked in your experience?
so this is awkward, but the lectures in general have been fairly ineffective.
What's made the lectures ineffective?
So some of the things that people said was that they were a lot of lectures were provided from like different universities. There was a lot of reliance on pre-recorded stuff from other instructors. So sometimes, in my opinion, it's very difficult to concentrate when you're on your computer at home. I mean, it's really easy to get sidetracked or maybe start working on other things while you're in class. Like maybe 1 minute you think that you know what the teacher's talking about, so like you get distracted by something, and then you tune back in to what they're saying, and you're completely lost, and then you just remain lost for 20-30 minutes, and then that just causes you to lose focus again. So that's something that I experience a lot. And then there's also people have computer issues, sometimes internet issues, bad microphones, and or they have trouble with screen sharing. Somebody wrote death by PowerPoint. I don't really have anything to elaborate on that, but I guess we could use our imagination.
They prepared a slide deck for you.
And then something I found troubling is that every teacher organizes their content differently on multiple websites, which forces students to create large folders of bookmarks for each term. Makes it very difficult to find things, particularly when important things are hidden in emails or Google Drive files. The D2L works great. I wish that teachers used it more. And if it is to be replaced, it should be replaced with something that teachers and students both can use to organize all content.
Thank you. Any ideas that they'd want to potentially try out in this class?
Well, we already mentioned Slack and Discord, but heavy use of Slack and Discord is something we like. It simulates the environment of study groups and that sort of thing. Usage of practical examples for complex topics, and clear expectations of requirements on programming assignments. That's another thing. Sometimes the descriptions for these assignments are very large, but the actual explanation of what the teacher's looking for isn't always clear. And I find with programming assignments that the expectations are generally a little bit clearer, but with like just question and answer homework assignments, the expectations can be really unclear. And then you get your homework assignment back and your grade, and you're just like, I'm just going to move on. I don't know. I totally misinterpreted that question, but it's not worth it.
Great. Thank you, Matthew. I appreciate all that. And thank you, Group 1. People in Room 2, who will be speaking on your behalf?
That would be me.
Thank you.
All right. So I wrote them all down. Let me load that up for a sec. All right. So it seems like you want us to go down linear through the list, so I'll do that.
And just the highlights. I think people are brainstorming a lot of things, like maybe the 3 in each category that resonated most with you.
Yeah. Okay. Then I'll just try to be quick. I think most of all, for me, the main thing I wrote was basically having constant communication back and forth really helps. In the one class that I did for Japanese in remote learning, I thought that I got a lot more from that class because you always have to be communicating. They will call on you every time. You know, you will not ever go through a class without speaking. And that means that basically you have to always be tuned in. You know, admittedly, I have definitely tuned out sometimes more than I should, but part of that is because, you know, if no one's talking to me, then, and they're just talking to the void, then I'm not really engaging as much. So having constant communication back and forth helps, like this. And then I found it a little funny that one of the notes was death by PowerPoint, because I would personally say that for me, maybe it's because I'm a visual learner, perhaps. I find that when the instructor is basically just going over code, making code, and talking over it without having like a visual representation of their main points, that hurts the presentation, because especially when like reviewing the video, which is an advantage of recorded lectures, of course, is, you know, having a recording at the end. But if all it is just like the same thing for every, you know, time code, it's hard to really be like, okay, at this point they're talking about, you know, classes and extending them. At this point they're talking about like making unit tests. So far this lecture has been pretty good in that regard, because there's been a lot of visual variety. And another thing, things that help is, yeah, Slack and Discord. One thing, elaborating a bit on Matt's point, is that Slack has like a 10,000 message limit. Once that's done, it goes away. It helps in this case that you have a Slack channel that is independent from the PSU CS Slack, because that runs out in like 2 weeks. But even so, Discord has no limit ever. So that's one advantage of it. And another thing is, an advantage of remote classes is that it's easier to take multiple classes since you don't have to commute, right? But a disadvantage is when you're in a group project, basically it's harder to manage sometimes, because if someone's not online, you can just, there's no way of communicating with them. And if they go offline for like weeks, it's just done. Whereas at least you can usually expect someone to appear in class at some point, so you can pin them down at least. And on that note, it's also harder to arrange group meeting times, because like when it's all remote, people usually have tons of other things going on. Whereas if they're always going to a physical class at a certain time at a certain place, you can know that at the very least, you might be able to get them for a group meeting like an hour later after lunch or something like that. That is an ineffective thing. And the only thing we really wrote for things that make classes, remote classes, a bit more effective, what can, is like visual representation of concepts. But that was basically just like leading back to what I was talking about earlier about having prepared slides or some kind of visual representation of what you're talking about, which helps with reviewing, as well as paying attention in the moment.
Great. Thank you. Group 3, who will speak on your behalf?
Oh, yeah, that's me, Jonas. And ours is pretty short. I wrote down the things we had in common. And so for the first one, what has been most effective for several of us, that was not having to spend extra time commuting and instead having that time for the work. And like personally, I feel like I would probably always want to have remote classes for that. And another one was that we had access to old lectures to review them. So that was a big help. And like I don't remember ever having that for an in-class course. And just like all the other groups, being able to ask questions on Slack and Discord was huge. And what was ineffective was basically that we don't have a way to really work over problems in person. And there's something about doing it in person that helps with office hours, and also like math help, a math help center, places like that. And then for the last, for making our class effective, We didn't have that much. I just felt personally that it helps if you can engage the students, like kind of like what Andrew said, that he was called upon. And so ask the students to like guess the result of, say, a math expression or code in our case, and that would help. And that's what I had for our group.
Nice. Okay, that's a good suggestion. Actually, I was going to do a little bit of that later tonight when we talk about the cones. So
Okay,
good.
cool.
Okay. Group 4.
Right, I believe that's me.
Okay, thanks.
All right, so a lot of our stuff's already been touched on, but it's like for creating Discord servers for going over like quizzes and sharing resources. And as the chat mentioned, another perk of Discord is the voice channels and screen sharing options. So that's just like more pretty useful options there. What was been ineffective for us in our remote learning classes was when a teacher would give a lecture and they didn't really respond to questions in chat or didn't really notice that chat was going, or would respond to them like 40 minutes after the question was asked and the material is way irrelevant now. And then also not going to class and just relying on the videos turned out to be pretty poor decisions for remote learning. And then ideas to make the class more effective would be just, as has been said, creating open environments that encourage participation and just having some study groups.
Great. Thank you. That was a question from, or not, a comment from on the chat. Also, it'd be great if we work on program activities in small groups during class, since we won't work in groups for a project. You'll have that opportunity here. I'll go in more detail next week, but we'll have four sessions of 2 mob programming, 2 pair programming. So there will be opportunities. Excellent. Thanks. Okay. Group 5, right? Yeah.
I'm going to talk for group 5.
Okay.
So we mostly talked about the stuff that's already there, the things that haven't been covered. What's been effective has been classes where they've done projects that expand over the course of the class, where basically you start with some small bit of code and then you keep working on it and you keep building it and keep building it. I assume that's what we're going to do in this class too. So
you are correct. Yep, we'll get to that next.
That's been really great. It's been very effective, and it is something that has created some degree of interaction in those classes. Another thing that's been effective has been anytime that a class has been treated as though it is an open book class. So where they give quiz questions or exam questions that are geared towards having to do research, having to go through resources, which you can do if you've been going to lecture and all, keeping up, but which you would struggle with just doing a Google search or something. As for what's ineffective, everything's been covered.
No, that's fine.
Ideas to make the class effective, workshopping. That's another thing I think you sort of said that we're going to do in this class, where we're splitting into groups, or we're basically doing live code together. And we are trying to create something. I think that's great. That's like a great way to actually practice for when you actually do work with code, because you will have to work with people then. So yeah, that's all we have.
Excellent. Thank you. Yes, and last but certainly not least, if there's anything left, group 6.
Yes, indeed. Yeah, so just briefly, most everything has been covered already, but just quickly, breakout rooms are a great thing. I think that has been a lifeline of connecting with other people and really getting that interaction. It's been great. And then one thing I've noticed with the virtual learning, it's, at least for a lot of the CS classes, it's hard to really focus on a lecture type format still. And I found like doing, like giving the material and do self-learning, and then having like labs and office hours and group hangouts is like the best way for me to learn, at least. I found that to be really useful. And then as far as ineffective, a couple of the people in our group have found, and I think this isn't true for everyone, but at least for myself, I think it's hard to do walkthroughs in class, just because when you have, there's not a ton of room on your screen, and you're like trying to watch what the teacher's doing and trying to keep up on your other tab, and then it's just almost too much to handle. And then I've also found just strict walking through lectures very ineffective with virtual learning. Just too many distractions and super hard to stay focused. And then just things to improve or add, not really much to add other than, like everyone was saying, I think building a vibrant group of interacting students and helping each other out has been the best way to work through a lot of this virtual learning for me and for a lot of people in our group.
Great. Thank you. You know what? Earlier today, I was looking through because I did this exercise last summer too. There's some very different answers, and it looks like people have really learned a lot, have figured out how to adapt, how to cope, and in some cases, but you're all so much more familiar with this. Of course, you've had an extra year of experience, but these are really good things, and good. I'm glad to hear that some of the things I plan to do, will likely resonate. But we'll inspect and adapt. We'll see how things go. We'll figure out what works and what doesn't. Please let me know how things are going. I can't see you, and so I can't read your body language. I can't, even if you're on camera, I don't necessarily what's going on, and so it's really hard for me to read the room. So I am relying on you to speak up and advocate for yourself. So put something in chat, and a direct message is fine too. If it's just like if you don't want, I was like, I'm really feeling lost, Dave. Cool. I'm not going to call anybody out, but it's a good signal to me that's like, okay, I should go through and address something or ask ask for a cue for for questions and such. So good, thank you. And yes, someone says they can't wait until in-person classes start. That's true. I know I'm missing people dearly also. But uh, it's still dangerous out there, and we want to make sure that there are enough people who are vaccinated and are safe that we can be out among the people who either aren't or can't be.
Mhm.
Okay. Okay. Let's. 9 o'clock. We got a little bit of time left, and we got a couple more things to cover. So we talked about a lot of stuff tonight, right? We talked about the course. We just started the Getting Started repository, and so now you've got this place for your code. And now I want to talk about the 2 projects that are assigned tonight. The first project is project 1 is the first project that we're doing. So this term we're going to build up an appointment book application. And it starts really simple, and that's on purpose. So, the goal here is to work with some code that didn't write, do some command line parsing, sort of get the fundamental pieces, parts in place. Don't worry, you're not going to be bored because there's lots of other stuff to do. And it's due in 2 weeks, so you have a tremendous amount of time to do it. So what we're going to write in this first project are the fundamental appointment and appointment book classes that you will then work with throughout the rest of the course. Even in your Android project, you're still going to be using these 2 simple domain classes. Probably to change them, but they're still going to be involved. So there are 2 classes that I provide you, which are the abstract superclasses for your appointment and your appointment book. They're called abstract appointment and abstract appointment book. And what you're going to do for this project is create 2 concrete classes in your own package that extend my classes, and they have some functionality. So each appointment book has an owner, and consists of multiple appointments. And so then you'll get to work with a collection to store all of the appointments in your appointment books. And every appointment has some description of what it is, like have lunch with Lisa, and it begins at a given time and ends at a given time. For this first assignment, it's okay to represent the times as strings. We'll be learning about the date class in a couple of weeks. So you can ignore the get begin time and get end time methods for now. There's also a class called Project One, which contains a main method that parses the command line, so it takes the arguments from the command line and does some simple, actually kind of stupid simple stuff. It creates a new appointment book and it creates a new appointment, adds that appointment to that appointment book, and the specifics of who the owner of the appointment book is and the description of the appointment, that's all from the command line. Adds the appointment to the appointment book and prints out a description of the appointment by invoking the toString method. And so this is the command line interface for your Project One class. So there are 4 arguments that are that are in this order. So the first program argument is the owner, description, and then the begin time and the end time. And we'll see the format for the begin and end. But preceding the arguments are 2 optional options. So before the arguments, there could be a dash print, which will print the description to standard out, or a dash readme, which prints something called the readme, which we'll cover next week. You can focus on the real functionality and worry about the readme later. If you really want to look ahead, there's a handout about documenting your code that explains what it is, but we'll cover it next week. And so again, the begin and the end should be 2 command line arguments of the form month, date, year, and hour, minute. As is the way command lines work, if you want to have multiple words in a single argument, you need to put them in double quotes. And dates and times, however, should not be quoted. Those each are 2 command line arguments. And examples of valid dates are 7/15/2021 and 0/6/2/2021. You can have any year, actually. I'm not going to validate that. Similarly, times are in 24-hour time, so 14:39 and 1:03 are valid times. We'll talk about what a POA, a plan of attack, is next time. Also, you can read ahead in the handout to find that out. Also, bunch of footnotes here. I'm trying to think. It's important. There is no reading of standard input in this class. Everything comes from command line arguments. This is the way I test it, and it's like working with standard input is lame. So you'll just send everything on the command line, please. And do note that the month and day can be expressed as either 1 or 2 digits, but the year is always 4 digits. So you're going to be again writing a main method in your Project One class with these command line arguments. A big part of this first programming assignment is error handling. It's just the nature of it. There's not a lot of functionality there, and so then what you'll be focusing on is things like parsing the date and making sure all the command line arguments are there. And if there is an error, I want the program to exit gracefully, right? Have a understandable user message. Don't do things like print stack traces. A null pointer exception isn't helpful to the user. Make sure that that you test your program, and you can even write unit. And next week we'll learn about integration tests that will help you validate all of that stuff. We'll also talk next week about how to submit your code, but know that we'll learn that later. And you can get started by running the create project one script. Now I'll run that real quick here. It's pretty much just like creating project 0. And then so you provide your name. Now we have an appointment, an apt book project, and the same thing. You gotta chmod the Maven wrapper, but then once you do, you can run verify. Dimitri asks, can you run scripts from the IntelliJ command line? You can give it a try. I think it'll work. I don't know that much about the IntelliJ shell, actually, so it might be okay, especially on like a Unix system. So if you're on Linux or a Mac, it's probably okay. give it a try. See how it goes. Let us know. Send a postcard. And once you've done that, you can go back to your project. Let's see here. And if you sync, if you refresh, maybe what I need to do is the Maven refresh. It's just thinking about it. Oops. Huh. That's a little surprising. I thought it would show up here. Let me quick take a look, see what's going on. Close the Maven. Oops. Sorry, I've just got way too much Zoom stuff here. Oh, really? Yeah, I just need to sync it. Sorry. It's really strange. So I'm a little surprised here that IntelliJ is not able to see the changes that I just made to the POM. Am I looking at the right Oh, you know what? I'm logged into the PSU machines. We'll do this backwards then. Okay, that's cool. Yeah, see, I am on the PSU machines. I created it here on PSU. I'll just add it here, and then what what I meant to do was to show how you can use GitHub to sync from PSU back to your local copy. So then let's see here. Appointment book. Oops, I'm already here. I will do a Maven clean. And now, look at my status again. I'll do git add of appointment book. Make sure I didn't add anything funny there. That all looks good. Now I'll add the pom.xml. And now I'll add files for project 1. Git push. It's going to ask for passwords. Gonna try to type it right this time. Oof, not too late at night. Oh, interesting. I need to do a git pull. But first what I'm going to do is I'm going to make it so I don't need to type my passphrase so many damn times. Okay, git pull. Okay, so here's what I just did. I had committed some changes locally. I had some changes that were in the remote repository. I've got to go pull and merge those changes from remote repository in. And these are for student. They didn't conflict with anything that I added. And now I can push it back to GitHub. And this is actually a really good thing, right? This makes sure that you don't have conflicting code that can't be resolved. Now that I've done that, I'm going to go back to IntelliJ. Well, first of all, I'm going to log out of here. So I'm back. Yeah, here I am back again on my own machine. Now I'm going to use the update project from Git. And what this will do is it will go out to GitHub and it'll get all of the changes, including the ones that I just merged in. And poof, there it is. Now it's got the appointment book module. And IntelliJ even recognized it as an IntelliJ as a Maven project. So that was a long way to say that I ran the create project 1 script and it created this new appointment book project. And it created an appointment class that extends abstract appointment. I'm getting tired, everybody. Which again is source code that comes from me. It's not in this repository, and it overrides these methods to throw unsupported operation exception. But this comes complete with sort of some beginning code. It's got a beginning project one with a main, and it also comes with a couple of unit tests to let you to let you test things. And we were talking about how to handle how to handle exceptions in unit tests. Well, you can use this assert throws, and we'll dive more into that later. But you might want to check out what this method does there and look it up to see what it's done. A quick, does assert throws call a panic? No, actually. Oh, does it cause a panic? No. Well, what it does is it says, hey, listen, right now, when I call get begin time string, I expect it to throw an exception. And actually, that's a nice thing to assert because it's like, oh, hey, listen, I expect that this thing will, this test condition will result in an exception, which is a perfectly valid thing to do. So anyway, use create project one to give yourself all these files to see everything like that. You can use Maven to oh, sorry, I got to update all that stuff. I'll do that. To run verify. Sometime else we'll talk about Maven site and what the site phase does. It's pretty cool. And including running some code coverage, and we'll talk about that next time also. But if you want to run the command line, then you use let's see here. Let's go back to appointment book, and then we got to run Maven verify. It's compiling everything. Here on my local machine. It's running the tests, running the unit tests. Then I'll build a jar. Then I'll run the integration tests, and we'll learn more about that next time. Nice. And so now we should have a jar file called appointment book .jar, and we will run it. Oops, what didn't I like there? Cannot load main class. Oh, interesting. I will have to look into that then. I'm not too sure why that didn't work. Sorry, just let me check one thing real quick. Oh wait, Whitlock appointment book? That ain't right. You might need to make that same change in your classes too. Sorry about that. Let's damn it. Maven package just to rebuild the jar. And now run the jar file again. Okay, now it seems to be doing the right thing. So, so important to note, and actually, please, as you know, after you run the script, let me know if you run into the same thing with yours. You very well may. You might need to adjust this main class in the pom.xml. So I will quick submit that, commit that. Fix the name of the main class in the pom. I need to look into that. Okay. Oops. So that in a nutshell is project one. Again, what you need to do is you need to write classes like appointment and appointment book. You'll need to write some unit tests for them. You'll also have a command line. You have a main method that parses the command line with this information on it. And if dash print is present, it prints the it prints the information, the toString of the newly created appointment. If dash print isn't there, it does nothing, which is kind of a dumb test case, but that's okay for project 1. It'll get more interesting in project 2, don't worry. And by the way, there's no persistence, nothing gets written, that's project 2. Very simple stuff for project 1. Any questions about that?
You want us to include our unit tests in the submission?
Yes, we'll talk more about that next week too. As a matter of fact, you'll have to. It's part of your grade, is to have a reasonable amount of code coverage. Yep. So, but more details about that next week. Just know now that you'll have to that you'll be expected to write unit tests. Okay. The last thing for tonight is the Koans project. So I've been using this for a number of years, and I found it's a really good way to get familiar with the Java language and some of the peculiarities, some of the specific things about it. So a cone is a teaching question. That's used in Buddhist discourse, and the whole idea is, it's supposed to be something profound thing, sound of one hand clapping, blah 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 blah. But the whole idea is that it's a discourse, in that there is an exchange, a volley back and forth between the teacher and the student, where the teacher asks a question, the student provides an answer, and it goes back and forth, back and forth, back and forth. And then over time, by doing a bunch of these little volleys back and forth, you then understand the bigger picture. And hey, sometimes there's an answer that's very subtle within the koan, but it's not like tricky. It's just that there's nuance there. Well, this dude on the internet named Matty B came up with this whole series of cones to teach you about the Java programming language and some of the APIs and how all this stuff works. And I found that's really great. You end up with these little snippets of code that you then make pass. They're like unit tests in that respect. And at the end, you've been exposed to a lot. And so this is what I use to help people get started there. And so then what you do is there's another project to create there in your repository, and this time you say create cones, and then give it your username. Okay. And this is a little different from the other projects in that it's like this has this little interactive program. So let me just make sure that it works. Let's see here. Make chmod the Maven wrapper, and then you say Maven. You say exec:\Java, which runs a Java main inside Maven. Okay. So you have this little prompt. So this prompt here is meant to be the teacher who is teaching you about Java. And so then here in IntelliJ, if you then go and synchronize things, you'll see that it's got a whole bunch of unversioned files and stuff like that. So let's see here. I think I can safely add all these files. Those look like Java files, and yeah, that all looks good to add. And so then I'll just right click here and say add to VCS. Now I've got 57 things. Okay, I'm just going to add all these to commit all these to GitHub. So add the Koans project. Why did I have it analyze the code? It'll take a minute here. Oof, that's slow. Commit and push, despite the warning. Let's commit and push again. Thank you. Okay, so now I've got that all in IntelliJ, and the whole idea here is that you're running this program, and it's giving you, it's telling you, where to go with the Koans, and it's saying, okay, there is a file called aboutkoans.java, and this is where your first lesson is. Okay, so back in IntelliJ, I'm going to shoot. I don't even know where the see navigate to file. So Command Shift N for me, and then ask you for the name of the file, and you're going to say about cones dot java, and you want the one that's just cone source beginner. And so then you've got this very simple thing. Actually, it's probably giving you some prompts here. It talks about, yes, there should be a method starting with @cone called find about cones file with it for your first lesson. Once you have solved that, save the file and check back for your next lesson. Okay. So, okay, this one right now is failing. What do we need to do to make it pass?
Simply delete the line.
Yes. Delete line 11. Okay. Delete that. And now I'll go back to my window. It notices the file has changed. It wakes up and tells you, okay, great. Now you've got something else. A cone is considered complete when it is no longer throws an exception. Often there is more than one way to solve a cone, but only one correct way. This is often hinted at within the cone itself or the comments appearing here. Ponder what's going wrong in the About Cones class's definition of a cone completion method. So go back to IntelliJ. Here's the cone method. What's wrong here? Yes, cone is complete. Shouldn't be false. It should be true. Now when I go back, it reloads and says, okay, yep, that's better. Congratulations, we've done our first one. And now let's move on to the next one, which is about assertions. So I'm going to open up the file again. Oops, about assertions. About assertions. Okay, this is now teaching you about the assert methods that the cones use are a lot like JUnit asserts, assert true, and a lot like Hamcrest assert that. And what you do in these cones is that you were for a lot of them you replace the two underscores here with some other value. So here, if we're asserting true, what should the value of the two underscores be? Yes, true. Let's see here, and looks okay. Now it's assert what's wrong with assert Boolean false. Okay, what should be here? Yes, false. You guys are getting it. Okay, so now, hello, that's good. Let's see here. Assert null object. So a reference to the object can be null, a magic keyword null, which means that there's nothing here. So what should assert null be? Yes, lowercase null. And we can check back on the command line to see if we're making progress. I bet we are. Okay, line 31. Now we're down here, etc., etc. Let's go through this one, and then I think you start getting the drift. What can we replace here with the two underscores? Some object. Null. Okay. Yes. Null because the reference becomes null. What should we put here? What is so this one is supposed to be not null. What's an example of a not null object? 4, 1. Let's see. Does that work? Yes, because now it's complaining about line 42. I think you're kind of getting the drift. And so then this is what this assignment is about. This assignment is about going through these tiny little exercises, and don't worry, it gets more interesting, right? You'll be learning about, boy, all sorts of things. Enums, how to handle exceptions. Yeah. Oh, interesting. Huh. And how to call methods, the finally block. The whole idea is that you work through these things pretty quickly. There are a ton of them, but overall you get just more experience working with the language, understanding more and more about what's there. So I'm going to commit these two. Start doing some cones. Okay. So there are a lot of them, and it's not meant to be a race. It really is something that I recommend that you just do a couple each day and sort of make a way through it. Or maybe you're sort of say, hey, great, I'm going to set aside an hour to just make a lot of progress and understand it. It's more about the journey, blah 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 blah. And as questions come up, if there's something that you can actually reach out on the Slack channel, because some of them are a little subtle or a little tricky. We'll talk about how to submit more things next time, but there's also a note here how to do it. And be sure, especially on the cones, to run them on the CS Department's machine. Sometimes I've seen some platform-specific stuff. I think I've gotten rid of all of it, but you never know. And so then this is an assignment that you have a couple of weeks. You have until July 21st, so I think that's 4 weeks. Start in on it soon because there's more than you think. Experience has shown that this is not something that you want to wait until the last minute to start, because there's a lot of them, and also by July 21st, your regular projects are going to get more complex also. So I think this one is due the same time as Project 3. Let's see here. How many are they, or when are they due? I just answer the when are they due. I think the answer, it tells you here there are 269 of the cone methods, and so then there's quite a quantity here. Okay, great. And so that is it. Who wrote that program? Matty B. So this dude. Oops. From Columbus, Ohio. He's eating somebody's head in his picture. That's neat. I don't know if eating somebody's head is a cool idea or not, but whatever. Can we do cones with friends? I prefer that you not. I'll say no. Anyway, good deal. Nice. Okay, that's all the content for tonight. So let's quick review. So, welcome to Advanced Programming with Java. Covered a lot of stuff tonight. We're all pretty tired. I'm getting the sun's going down. It's getting dark out here. I'm now being like spooky lit by the by the computer. So obviously it's time to end. We please go home and work with the Getting Started repository. And make sure that you can get yourself set up with a private repository in GitHub that has got the content, that you've got all the scripts, and create the project 1 and cone script. You don't have to do the project 0. I'm going to work with that a lot here in class. We don't have to do that one. And then make sure that you can build those projects, that you've got Maven working, that you've got Java working. And also watch the lectures that are referenced here on the webpage. Please check out the ones for week 1, and then also watch the ones for week 2 before next time. There is a quiz that is due next week. It's on D2L.
What day specifically is it due?
I'm pretty sure it's due the same. It's right before class.
Okay.
Pretty sure it's Wednesday at 5:30. Oh, you thought it was a digital background? No, I'm outside. Now I'm getting eaten by bugs, so it's time for me to go in also. So let's see here. And do we have TA office hours? No, not specifically. And we have graders, and so then, they need to focus on. We only get them for 6 hours a week each. They need to focus on grading, and so then in terms of support and stuff, I'll provide that as best I can on Slack, and I encourage you to ask questions in open forums, and so that you can leverage the knowledge and understanding of other people in the class. Did the neighbors get a Java lesson? Yes, whether they wanted to or not, just like you. Yeah, excellent. So, that's all I got. Any questions before we break?
Would you suggest that we start on the Koans before Project One?
No, I mean, they're really meant to be done in parallel. Depending on how familiar you are with Java, maybe it's been a long time and you want that refresher. Sure, invest some time just sort of reminding yourself about the Java programming language. But it's, sort of meant to be the Koans is a kind of, longer duration thing. It's the peanut butter that you're spreading over the project. I'm hungry. Anyway, yeah. So no, it's not really before or after. It's probably in parallel.
And so you said the book is basically a reference. In that sense, is there really like nothing at all specifically assigned for reading?
No. Nope.
Okay.
It's hey, there's a question you want to learn more about the Java IO APIs. Great, dig into that. And the textbook I like, but it's old, like me. And but also any online resource will probably give you something a little bit more up to date. And you can use Java 16, so you can use the latest stuff that's out there if you want.
Okay. And one thing I just remembered was there was a question during the break originally about a missing module error. They loaded the pom.xml in IntelliJ, and then they could not build it because basically they hadn't set a JDK. I was wondering how to do that.
Oh, yes, that's a good point. That's something that I did long ago. You need to go up under settings and under, I think it's project structure. Yeah, project SDK. And so then you have a choice here, and then you can edit them and add new ones. And then you find your JDK installation on disk and point it at that.
All right, and that will basically solve the problem they had with not being able to build it.
Good.
Yes, right. It will.
Missing module error. I don't know exactly what that means, and so then, or actually, maybe if I saw a screenshot, I would understand. So, but if you're having problems, please reach out on Slack. And in general, just like any bug report or like anytime you call customer support, try to provide as much context as possible. So say, here's the command I wrote. It's a given when then. I was logged into the I was logged into the PSU machines and I ran this command and then I saw this output. What? Right? So that is much more actionable than just saying, oh, I can't run on the PSU machines. Can't run what? What do you see when you run? You'll get a much better response. And you'll get your answer. You'll get question answered much more quickly if you provide some context.
Okay, and I think it was Matt had the Discord link, right? Do you want to repost that now that we're at the end of the lecture?
And to be clear, I do not plan on participating in Discord. So, sorry, I'm choosing one tool. It's going to be Slack.
Yeah, that makes sense.
And so then that's all for you all. Yeah, I mean, feel free to do it. But I won't be on there, and so then any question that you want my input on will should be asked in Slack.
Got it.
Phew. And there was a question also came up about, let's see, I set up the repo before class, and I set up the repo again with a different name during class. Will I need to delete one of the repos before submitting my first project? No, you can, the name of your repo can be anything. What's most important is that it's got the scripts and everything like that. Really, ultimately the repo is for your benefit. And also, I've had a lot of students over the years that are like, I'm having problems getting something to work, or I can't get something to compile. You can make me a collaborator on your GitHub repo, and therefore I can see your code. It makes it much easier for me to debug things when I can see your code. You can't see me though. Woo. Anyway, sorry. Okay. Phew.
You said that this the first one is likely to be the longest. Do you think then that this is pretty much likely to be the longest now that you've gone through it?
Yeah. I mean, we'll have a lot to cover next time too.
Okay.
But in the future, I'll be able to turn down but we'll be doing more coding, and so that's a little easier for me to turn up or turn down the dial. But yeah.
Okay. Yeah, got it.
Excellent. Okay. Also a question about yeah, it says to replace strings your user ID and your GitHub user. Is this required? It might not be required, but we're going to see how it's used next time or maybe the time after. So you don't have to do it now, but if you want to build that Maven site and if you want to deploy the Maven site to GitHub IO, you'll want to do that. But we'll say that for another time. Okay. Sweet. Okay. Well, have a great night, everybody. Thanks for sticking with me. I'm going to download the recording and then upload it to YouTube as soon as it's ready. It might not be available until tomorrow morning. I will post on the class recordings channel in Slack when it is. Okay.
All right.
Bye, everybody. Hope to see you next week.
Thank you.
Thank you.
Good night. You're welcome.